So up until this point of the course, we have learned a lot of JavaScript features and syntax, and also how the language itself works behind the scenes. But now it's time to take a step back and talk about the whole process of actually building modern JavaScript applications in the real world. So this section is not really about the language itself, but more about the development process. So the modern build tools that every professional developer uses, and also the whole modern ecosystem that has been created around JavaScript. Let's start this section with a general overview of modern JavaScript development. So basically, of how we write JavaScript today. Because when we build applications, we don't just write all of our code into one big script, send that script as it is to the browser, and call it a day. Now it used to be like this, but the way we build JavaScript applications has changed tremendously over the last couple of years. So back in the day, we used to write all our code into one big script, or maybe multiple scripts. But today, we divide our projects into multiple modules. And these modules can share data between them and make our code more organized and maintainable. Now, one great thing about modules is that we can also include third-party modules into our own code. And there are thousands of open source modules, which we also call packages, that developers share on the NPM repository. And we can then use these packages for free in our own code. For example, the popular React framework, or jQuery, or even the Leaflet library that we used before in our Mapty project. All these packages are available through NPM. Now, NPM stands for Node Package Manager because it was originally developed together with Node.js and for Node.js. However, NPM has established itself as the go-to repository for all kinds of packages in modern JavaScript development. Now, in order to actually download and use and share packages, we use the NPM software installed on our computer. And this is just a simple command line interface that allows us to do all that. So basically, NPM is both the repository in which packages live and a program that we use on our computers to install and manage these packages. So let's say that we are done writing our project code. So we divided it into multiple modules and we included some third-party modules as well. And so now the development step is complete. However, usually that's not the end of the story. At least not when we're building a real-world application. Instead, our project now needs to go through a build process where one big final JavaScript bundle is built. And that's the final file which we will deploy to our web server for production. So basically, it's the JavaScript file that will be sent to browsers in production. And production simply means that the application is being used by real users in the real world. Now, a build process can be something really complex, but we're going to keep it simple here and only include 2 steps. And the first step will bundle all our modules together into one big file. This is a pretty complex process which can eliminate unused code and compress our code as well. Now this step is super important for 2 big reasons. First, older browsers don't support modules at all, and so code that's in a module could not be executed by any older browser. And second, it's also better for performance to send less files to the browser, and it's also beneficial that the bundling step compresses our code. But anyway, as a second step, we do something called transpiling and polyfilling, which is basically to convert all modern JavaScript syntax and features back to old ES5 syntax, so that even older browsers can understand our code without breaking. And this is usually done using a tool called Babel. So remember that I said right in the beginning of the course that we were going to do this, and in this section we will finally do it. So these are the 2 steps of our build process, and after these 2 steps we end up with that final JavaScript bundle ready to be deployed on a server for production. Now, of course, we don't perform these steps ourselves. Instead, we use a special tool to implement this build process for us. And the most common build tools available are probably Webpack and Parcel. And these are called JavaScript bundlers because, well, as the name says, they take our raw code and transform it into a JavaScript bundle. Now, Webpack is the more popular one, but it can be really hard and confusing to set it up. So that's because there's a lot of stuff that we need to configure manually in order to make it work properly. Parcel, on the other hand, is a zero configuration bundler, which simply works out of the box. And so in this bundler, we don't have to write any setup code, which is really amazing. So I personally absolutely love Parcel, and I use it all the time, and I think that you will love it too. And so that is the JavaScript bundler that we're going to use later in this section. Now, these development tools are actually also available on NPM. So just like packages that we include in our code, we will download and manage tools using NPM as well. And these tools include the live server that we've been using all along, the Parcel bundler that we just talked about, or Babel to transpile code back to ES5. All right, so this is a high-level overview of how we develop modern JavaScript applications today. And if you ask me, this is really exciting stuff, because this is how professional developers actually write JavaScript today. And so in the rest of this section, you will take a big step in the direction of becoming a professional developer too. Modules are a super important part of software development. And so in this lecture, we're going to talk about modules in more depth and learn how they work behind the scenes. So essentially, a module is a reusable piece of code that encapsulates implementation details of a certain part of our project. Now, that sounds a bit like a function or even a class, but the difference is that a module is usually a standalone file. Now, that's not always the case, but normally when we think of a module, we think of a separate file. So, of course, a module always contains some code, but it can also have imports and exports. So, with exports, as the name says, we can export values out of a module. For example, simple values or even entire functions. And whatever we export from a module is called the public API. So this is just like classes, where we can also expose a public API for other code to consume. Now, in the case of modules, this public API is actually consumed by importing values into a module. So just like we can export values, in modules we can usually also import values from other modules. And these other modules from which we import are then called dependencies of the importing module, because the code that is in the module that is importing cannot work without the code that it is importing from the external module, right? And this entire logic that I just described is true for all modules in all programming languages. So this is not specific to only JavaScript. In fact, modules are a pattern that developers have been using in all languages for decades. Now, of course, we can write code without modules. And actually, we've been doing that up until this point. But that's because our applications have been very simple. However, when a codebase grows bigger and bigger, there start to be many advantages of using modules. And the first one is that modules make it really easy to compose software. So we can think of modules as small building blocks that we can then put together in order to build really complex applications. And I think it might be helpful to look at a more real-world example to understand all the benefits of modules. So let's take this digital camera. You can see that this specific camera is basically made up of all these modules that we can see here. And this is exactly how we can compose software using modules as well. Another big advantage of these camera modules is that each of them can be developed in complete isolation. So you can have one engineer working on the lens, and another one on the screen, and even another one on the controller module. And the best part of this is that each engineer can actually work on their own module without even understanding what the other engineers are doing, and also without understanding how the entire final camera works itself. And so, isolating components is another huge advantage of using modules. And again, isolating components essentially means that each module can be developed in isolation without the developer having to think about the entire code base. He doesn't even need to understand all of it, which makes it really easy to collaborate on a larger team. Next up, modules make it very easy to abstract our code. And we already talked about what abstraction means, but basically we can use modules to implement low-level code. Then other modules, which don't really care about these low-level details, can import these abstractions and use them. And back to our camera, the screen module, for example, does not care about the low-level implementation details of the controller module. It can simply import the controller, but without knowing how it works, and use it to control other parts of the camera. And so that's essentially the power of abstraction. Modules also naturally lead to a more organized code base. Because when we break up our code into separate, isolated, and abstracted modules, this will automatically organize our code and make it easier to understand. And so this alone is a huge benefit of modules. Finally, modules allow us to easily reuse the same code in a project and even across multiple projects. For example, if we use a module to implement a couple of mathematical functions in a certain project, and if we then need the same functions in the next project, all we need to do is to copy that module to the new project. And in our camera example here, this company could now use the exact same lens or the exact same screen in different camera models, all because they nicely abstracted these components into self-contained, reusable modules. Alright, so this is how modules work in software design in general. But now let's take a look at modules specifically in JavaScript. So as of ES6, JavaScript has a native built-in module system. Now, we did have modules before ES6, but we had to implement them ourselves or use external libraries. So, ES6 modules are modules that are actually stored in files. And each file is one module, so there is exactly one module per file. But now you might be thinking, well, scripts are usually also files, right? And that's of course true. And so let's now compare these two types of files in order to understand that there are actually huge differences between old school scripts and modern ES6 modules. The first difference is that in modules, all top-level variables are scoped to the module. So basically, variables are private to the module by default. And the only way an outside module can access a value that's inside of a module is by exporting that value. So just as we learned in the last slide. But if we don't export, then no one from the outside can see the variable. Now in scripts, on the other hand, all top-level variables are always global. And I showed you this in the mapd project. Remember? And this can lead to problems like global namespace pollution, where multiple scripts try to declare variables with the same name, and then these variables collide. So private variables are the solution to this problem, and that's why ES6 modules implemented it like this. Next, ES modules are always executed in strict mode, while scripts, on the other hand, are executed in sloppy mode by default. So with modules, there's no more need to manually declare strict mode. Also, the this keyword is always undefined at the top level, while in scripts, it points at the window object, right? Now, as we learned in the last slide, what's really special about modules is that we can export and import values between them using this ES6 import and export syntax. In regular scripts, importing and exporting values is just completely impossible. Now, there is something really important to note about imports and exports, which is the fact that they can only happen at the top level. So, as you know, outside of any function or any if block. And we will see why that is in a second. Also, all imports are hoisted. So no matter where in the code you're importing values, it's like the import statement will be moved to the top of the file. So in practice, importing values is always the first thing that happens in a module. Okay, now in order to link a module to an HTML file, we need to use the script tag with the type attribute set to module instead of just a plain script tag. And finally, about downloading the module files themselves, this always automatically happens in an asynchronous way. And this is true for a module loaded from HTML, as well as for modules that are loaded by importing one module into another using the import syntax. Now, regular scripts, on the other hand, are downloaded by default in a blocking synchronous way, unless we use the async or defer attributes on the script tag. So that's a great overview of ES6 modules. But now let's dig a bit deeper and really understand how modules actually import other modules behind the scenes. And to do that, let's analyze what happens in this small code example. So here we're importing a value called rand from the math.js module and showDice from the dom.js module. Now, as always, when a piece of code is executed, the first step is to parse that code. Remember? So we talked about that way back. But remember that parsing basically means to just read the code, but without executing it. And this is the moment in which imports are hoisted. And in fact, the whole process of importing modules happens before the code in the main module is actually executed. Okay? So in this example, the index.js module imports the DOM and math modules in a synchronous way. What that means is that only after all imported modules have been downloaded and executed, the main index.js module will finally be executed as well. Now, this is only possible because of top-level imports and exports. That's because if we only export and import values outside of any code that needs to be executed, then the engine can know all the imports and exports during the parsing phase. So while the code is still being read before being executed. Now, if we were allowed to import a module inside of a function, then that function would first have to be executed before the import could happen, right? And so in that case, modules could not be imported in a synchronous way. So the importing module would have to be executed first. But you might ask, why do we actually want modules to be loaded in a synchronous way? Isn't synchronous bad? Well, the answer is that this is the easiest way in which we can do things like bundling and dead code elimination. So basically deleting code that's actually not even necessary. And trust me, This is very important in large projects with hundreds of modules, and that includes third-party modules, from which we usually only want a small piece and not the entire module. So by knowing all dependencies between modules before execution, bundlers like Webpack and Parcel can then join multiple modules together and eliminate that code. And so essentially, this is the reason why we can only import and export outside of any code that needs to be executed. So like a function or an if block. But now let's move on here. So after the parsing process has figured out which modules it needs to import, then these modules are actually downloaded from the server. And remember, downloading actually happens in an asynchronous way. It is only the importing operation itself that happens synchronously. Okay? Then after a module arrives, it's also parsed, and then the module's exports are linked to the imports in index.js. So for example, the math module exports a function called rent. And this export is then connected to the rent import in the index.js module. And this connection is actually a live connection. So exported values are not copied to imports. Instead, the import is basically just a reference to the exported value. So like a pointer. So when the value changes in the exporting module, then the same value also changes in the importing module. And this is quite important to understand because it's unique to ES6 modules. Other module systems do not work like this, but JavaScript modules do. And so you need to keep that in mind. But anyway, next up, the code in the imported modules is executed. And with this, the process of importing modules is finally finished. And so now, as I already said, it's time for the importing module to be finally executed as well. So index.js in this example. All right, and by now you're probably tired of listening to me, and so let's quickly move on and actually try all this with actual code. Let's now use modules in practice to make sure that we really understand how they work and to import and export values between them. And let's start with the simplest scenario of all, which is to simply import a module but without importing any value. And so that's also possible, and so let's use that as a starting point here. So let's then create a new module. Okay. So as always, we already start with this script.js, but now as we create a new module, we simply have to create a new file. So new file, and here I will use the example of a shopping cart. And so we're going to have a module called shoppingcart.js. And in module names, it's also a convention to use camel case names. All right. So this one here will be the importing module, and this will be the exporting module. And to start, let's actually log this to the console just so we can see that the module is actually being imported. So this one here will log to the console exporting module, and this one should log to the console importing module. So like this, with the quotes, of course. And now we also have to import that other module. And let's do that here first. So import, and then a string with the location of the module. So /, which simply means the current location, and then here VS Code already gives us these options. So let's choose here shoppingcart.js. And you see that VS Code automatically omits the JS here. So the name is actually this one with the JS, but ES modules actually also work without the extension. But for now, let's actually leave the extension there just to make it a little bit more clear. So let's start this code here. So as always, live server, but then we will see that this is not yet going to work. So let's take a look at the console here. And so we see cannot use import statement outside a module. So why is that happening? Well, remember from the last lecture that when we want to connect a module to the HTML file, we actually need to specify the type attribute. So here we have to say that this is of the type module. Okay? And so now it actually worked. So let's go back here and analyze this. And so here in the console we see that the first log is actually exporting module. Only then importing module is logged to the console. And so this means that in fact this code here is executed before any code in the importing module. So exactly what I explained to you in the last lecture. So the code in this module here is parsed, and before it is executed, all the code in the modules that it imports is executed first. All right? And the same is true if we had this log here before. Okay? So remember that all the importing statements are basically hoisted to the top. And so usually this is actually also how we write it. So all the import statements at the top of the file. And also note how I didn't use strict mode here. And that's because, as you learned in the last video, all modules are executed in strict mode by default. But now let's go back here to the shopping cart module and define some variables. So let's just say shipping cost equals 10. And let's also say we have an empty cart, which is like an array. So an empty array for now. Now, variables that are declared inside of a module, so just like these two ones here, are actually scoped to this module. So basically inside a module, the module itself is like the top level scope. And so by default, this means that all top level variables are private inside of this variable. So unlike traditional scripts, which would put all of these variables here in the global scope. But again, not modules. And so that's why right here, we cannot do this. All right, so shipping cost is not defined. All right, so the shipping cost and cart variables are scoped to the current module, basically. And so we can only use them here. Now, if we wanted to use them in the script.js module, then we would have to use exports. And in ES modules, there are two types of exports: named exports and default exports. And named imports is actually the simplest way of exporting something from a module, because all we have to do is to put export in front of anything that we might want to export. So let's say that we want to create this method here, add to cart, and it should be a function that takes a product and a quantity, and then it pushes basically a new object to the cart, so to that cart array. And then let's also log something to the console, like quantity, and then the product was added to the cart. Okay, and so again, by now, this variable is private inside of this module. But if we wanted to now export it so that we can import it in some other module, all we have to do is write export right here. And so this then creates a named export from this module. And so now we can then import that variable right here. We just have to write it with the exact same name. So the variable is called add to cart right here. And so right here in this module. And so therefore we have to call it that here as well. Now what we're missing here is the from. So this is quite easy to understand. It reads just like a normal sentence. So we want to import add to cart from this module. And again, add to cart, this variable name here, has to be exactly the same as this one. Okay, now here we are just missing actually curly braces around this here, like this. And so now it's going to work. And the syntax without the curly braces, we will see a little bit later. But again, with named imports, you have to give them here the same name, and you actually have to put them inside curly braces like this. And so now here we are able to call this function as if it was defined here in this same scope. So let's just say we want to add 5 breads to that shopping cart, and now indeed it works. So here we get that log now that is coming from the add to cart function that is indeed defined in this module here. Now just keep in mind that exports always need to happen in top level code. So it wouldn't work like this. All right. So then indeed you get an unexpected token export. So let's put it back, of course. And so now here we are back. And of course, we can also export multiple things from a module using named exports. And actually, that is the main use case of named exports. So basically, when we want to export multiple things. Okay, now we can also export multiple things at the same time using named exports. So we can just, let's say, declare some variables here, like total price 237 and total quantity, let's say 23. And so now we can export all of this at the same time, again using named exports by writing total price and total quantity. So this is a little bit like exporting an object from this module. And so now, just like before, we can then come here and import these variables using the same name. And again, that's inside of the curly braces, just like we exported here. So that's add to cart, total price, and total quantity. And so of course we can then go ahead and use them here. And in this case, all we do is to log them. But indeed, now we get access to these values from here. And indeed, now we get access to these values here in this main importing module. Now, actually, we can change the name of the imports as well. So for example, if we wanted to call the total price simply price, we could write this. So total price as price. And so then here, it would no longer be called total price, right? So it's no longer there, but instead it is simply called price. And we could actually even do that here in the exports. So here we could also write like export total quantity just as QT, let's say. And so then here it would no longer be called total quantity, but TQ. And now that doesn't work, so let's go back. So it's TQ, so total quantity. And so now indeed we are back to having 23 there. So this is all very flexible, as you can see, and we can play around with this as we wish. Okay, and actually we can take this importing even further, because we can also import all the exports of a module at the same time. So that's import, and then everything. So that's usually the meaning of the star, and then as, and here we can give it some name that we want. So let's call it shopping cart, and with a capital S here. So a little bit like a class name, okay? So that's kind of the convention when we import everything into an object like this. So basically this here will create an object containing everything that is exported from the module that we will specify here. So from shopping cart. And so this will then basically create a namespace for all of the values exported from that module. Let's just comment out this one here, and I will put this code that is more related to this import here. So actually I want all of it here. So put that here and comment it out like this, because now we are doing it differently. Let's just put everything here, just so we get some new code here. Now it tells us that this module doesn't exist, and that's because by default VS Code again removed this JS. And in fact, it is necessary. It is only not necessary in some other cases that we will see later. So now it works again, and we are back to having our logs here. And so now whenever we want to use something that was exported, like this add to cart function, then we have to basically take that from this object. So add to cart, and let's again say bread 5. All right, so here it is again. And so basically, if we think about this, this module here is now basically exporting a public API just like a class. So it's as if this object here was an object created from a class, which now has these methods and also, for example, these properties like shopping cart dot total price, right? So that's the other named export from this module. Now, of course, we are not trying to replace classes with modules. I just wanted to turn your attention to the fact that some things here look pretty similar indeed, right? And actually, we can say that a module exports kind of a public API, because everything else, of course, stays private inside of the module. All right, and that's basically how named imports and exports work. So we saw how we can export just one value, and also how we can export multiple values at once, and also how we can change the name of the named exports and also of the named import like this. Then we learned how we can import everything at the same time, so all the named imports at once. All right, and so now it's time to talk about default exports. So I said that they were named exports and default exports. And so let's now talk a little bit about these export defaults. So usually we use default exports when we only want to export one thing per module. And so that's the reason why they are called default. And so it works like this. So pretty similar, but then we have to write default. And then here we want to simply export a value. So for example, if we wanted to export the same function, we would simply export the value itself, so not the variable. And here you see that no name is involved at all. We are simply exporting this value. And so then when we import it, we can basically give it any name that we want. So let's say import add from shopping cart.js. And so this will then import the default export no matter what that's called. And in fact, it's not called anything. And so yeah, we can give it any name here that we want. And right now, we are actually importing the same module here twice, as you see. Now that's not a problem, as you see here now, but usually we don't do that. Okay? So we didn't get any error, but it is also not advisable, I would say. So let's take this out here for now. And now let's once again try to actually use the value that we imported here. So let's add 2 pizzas, and here they are. All right. And we could even mix all of them in the same import statement. So if we wanted, we could have default and named imports and exports all at the same time. So here we would just have to take this one and then put that here after a comma. And then we could take a look, for example, add the price once again. All right. However, in practice, we usually never mix named and default exports in the same module. So this is not really desirable here. Let me just comment it just so you see that we can do it. But I will then leave it as it was before. All right. So of course now the price is not defined. But now we should be good to go. So the preferred style is actually to just use one default export per module and then import that here like we did. And in fact, that's the reason why it is easier to import a default export. So here we don't even need to use the curly braces, and the designers of the specification did that on purpose. So again, to make it easier to import default exports. But of course, that's not a rigid rule that we always need to follow. So we can do whatever is best for any given situation. However, what you probably should really not do is to mix default and named exports like we did here. So avoid that to reduce complexity, but besides that, you can use named exports or default exports, whatever works best in your situations. Now, of course, we will use all of this in the real world in our next big project, and so by then you will get a good feeling for how all of this works a little bit better in the real world. All right. But with this, you now already have a pretty good idea of how importing and exporting values between modules actually works. But before finishing this lecture, I actually also wanted to prove you that imports are, in fact, a live connection to exports. So that's something that I mentioned by the end of last video, and it's something really important to keep in mind. And so let's take a look at this. And so actually what I will start doing is to now export this card array here. All right. So here now it looks as if we are simply exporting this empty array here. So card is an empty array, and that's all we are exporting here. But now watch what happens as we add a couple more products. So let's say bread, 5, and then just a couple of apples. And so watch what happens when we now import this card and log it to the console. So actually let's do that here. So I mentioned we should not mix them, but now just to make this work, we actually need to. So we're mixing a default export and a named export, but never mind. Okay, so everything is added to the card, and now let's log the card and see what happens. So here we do not see that empty object that we exported, but instead we have this array with the objects that we just added to the card by calling the add function here. And so that proves that this import here is in fact not simply a copy of the value that we exported here, right? Because if it was, then here we would simply get that empty array, right? Because that's what this card variable looked like by the time we exported it. But as I mentioned in the last lecture, it is not simply a copy. It is a live connection. And as we call this function that we called add in the other module, we keep pushing objects to that array. So we are mutating that array here. And so then here, of course, we see that manipulating the array in the console as we log the card here. And so they are, in fact, the exact same object behind the scenes, basically. So one more time, repeat it with me. Imports are not copies of the export. They are instead like a live connection. And so what that means is that they point to the same place in memory. Because again, otherwise, if it was a copy, then here we would not get anything in the array. And so keep this in mind when you write your own programs, because this can of course lead to bugs if you don't know what you're doing and if you don't know that this is how it actually works. All right. And so with this, we actually finished this video, which was a pretty important one because this is the foundation of how we organize a modern JavaScript codebase. So make sure to review this lecture thoroughly, and I would actually like you to play around a little bit on your own with exporting and importing some more values like we just did here. And after that, I see you then in the next video. Let's now shortly go back to asynchronous JavaScript, because there has been an important change in ES 2022. So starting from this new ES 2022 version, we can now use the await keyword outside of async functions, at least in modules. So that's why this is here in the modules section. So again, as I just said, because this is really important, we can now basically use the await keyword outside of an async function, which we call top-level await. Just remember that this only works in modules. If we were going to try this in a normal script, like we have been using before this section, then top-level await would still fail. So it would not work at all. But here in our HTML file, we can still see that we have our type set to module. So this is what is required in order to make top-level await actually work. So to show you top-level await, let's simply do a simple fetch request. So the fetch function, remember, is what we do to do an HTTP or an AJAX request. And now let's use a new API that we haven't used before, which is a very simple one, simply with some fake data. And it's called JSON placeholder. So just Google JSON placeholder, and probably it is then this very first result. And here we can get fake data about posts, comments, albums, and all of this. But here, what I'm interested in is these posts. So just copy this URL here, and then that's really all that we need. So let's put that here. And now it's time to use that top-level await. So we can await the result here and then save it into some variable. All right. But remember that then we need another await to parse the data as JSON. So here I'm not explaining deeply again how all of this works. So how the fetch function works and how the JSON works, because we went through that in great depth in the previous section. Okay, and then we can log the data simply to the console. So let's give it a save and see what happens. And indeed, here is our data. So we have an array of 100 posts here, where each of them is this object here. All right, so basically that's how you use top-level await. And so we see that indeed the await keyword is now working outside of an async function. So before we would have to write async function something and then the function body. But now with top-level await in modules, that is no longer necessary. Now, what's really, really important to understand here is that while this is all great and very useful, this actually blocks the execution of the entire module now. And as we learned in the previous section, that is sometimes not exactly what we want. So let me actually demonstrate that to you by logging something else here afterwards. So just something really. And I will also make this request here a little bit slower. So let's come here to the network tab. And here then I click on throttling, and let's use a slow 3G. Then let's clean this here and reload. So you see that it's now taking up quite some time, and especially now here, this part, where it's actually fetching some data. So let's actually log something here before also. So start fetching. So that will make it a little bit easier to see what's happening. So let's reload here again. So now it all takes a lot of time because the network is really slow. So you see start fetching, then it's doing the work, and only after that it is really logging this something here to the console. And so in fact, this await keyword here, which is now outside of an async function, is blocking the entire execution of this module, which is something that we had never seen before. So this really wasn't possible before we got top-level await in JavaScript. Now, of course, this can be useful in some situations, but many times it can also be harmful, and especially if it's a really long-running task. So just as we learned in the last section, right? And if you don't remember that very important video from the last section, then you can just check it out. I think it's the first video in that previous section. But anyway, long story short, just make sure that you use this new superpower that you just got with great caution. All right. Now, this example here illustrates exactly how top-level await works, but it's a bit too simple. It's not really real-world enough. So let's actually get a little bit more real. So many times we have the situations where we do have an async function that we want to return some data. So let's actually try that. And I will just comment out this code here for now. Okay, and so let's create a function here called getLastPost. So this function will basically do this fetch request here and will then only return the very last post. So this is an async function. It doesn't need any input data. And then let's just copy these 2 lines of code here. And let's again actually log that data here so we can take a look at what we receive here. So for now, let's just call it so that this code here actually executes. And to see this, I will now turn off this throttling. So we no longer need this. This was just to show you the blocking effect of top-level await. Okay, so that's pretty fast now. And remember that now we want to return something from this function. And I simply want to return an object which contains the title here and, let's see, also the body. So let's say return, and we're going to return a new object with the title of data, which is this entire array here. And then we want to get the last element. Now, how can we do that? Well, let's actually use the new ES2022 add method. And if this is the first time that you're seeing or that you're hearing about the add method, then check out a new video that I also added to the array section. So right at the beginning of that. But anyway, we can just use data.add and then -1. Which will basically get the very last element of an array, and then .title. And then the other one is called the body, but let's just call it text here. So text is data at -1 dot body. Give it a save. And now here let's try to save that variable, or actually that returned value, into a variable called last post. Okay. Now, if you remember the last section, then you will remember that this is not going to work. So let me show you what last post is actually going to be. So you see, it is actually a promise. It is not the object that we were expecting. And the reason for that is that calling an async function, which this function here clearly is, will always return a promise. It will not return the actual data itself, because by the time we are running this line of code here, the data has not yet arrived. So we still have that pending promise. And again, if you don't really remember the specifics here, you can always go back to the last section. All right. Now the workaround that I showed you before, so to actually get this data here, so this object instead of the promise, was to simply use regular promises. So we can take this promise here that is returned and stored in this variable, and then on that we can call the then method. Then in the then method we get access to the resolved value, which we can just call last, and then let's just log it to the console. And of course it's not called lost, but last. And so after some time, here we get that object. So with the title and the text. However, doing this isn't very clean. Not very clean. And so what we can do now is to use top level await for this. So let's call it last post 2 this time, which will be the result of awaiting get last post. And let's see. Of course, it takes some time, but then here it is. So here is the result of awaiting this promise here now. So the promise returned from this getLastPost function. And it's in situations like these where top-level await actually can get quite useful. All right. Now to finish, I just want to show you one more important implication of using top-level await. And that is the fact that if one module imports a module which has a top-level await, then the importing module will wait for the imported module to finish the blocking code. So that sounds a bit complicated, and it sounds more complicated than it actually is. So let's just demonstrate this with an example. So let's come here to our shopping cart module, which is a module that we import right here. So remember from the last lecture that here we are importing the shopping cart module. And so let's now just add some blocking code here. So maybe just here in the very beginning. So let's say start fetching users, because this time we will actually fetch users. Let's copy all of this. And this is really just to have some blocking code, so we don't even need to store the result anywhere. And here, instead of posts, we can use users. But in this case, it doesn't really matter because we're actually not even saving the result anymore or anywhere. So finish fetching. All right. And now to see this effect again, we should probably throttle that request again with a slow 3G. So going back here. So the first thing that's going to happen is that the shopping cart is imported. And so now we start immediately the start fetching users. Then only after the fetch is completed, we get this second console log here. So that's this one. And only after all that, the code in the importing module, so in script.js, is actually executed. So let's see that again in action. And so we will now be able to see that the code in script.js actually has to wait for the code in shopping-cart.js to finish. So this top-level await that we have here is in fact blocking the execution not only in this module, but also in the module that is importing it. So again, it's very important to remember that using top-level await, so await outside of any async function, will block the entire module in a way that we really couldn't block code execution before. And so this is not only a really helpful tool, but also one that we need to use with great care. But anyway, let's now deactivate this code here so that it's not going to block when we start going to the next lectures. All right. And so, yeah, I think we're finished here. this is how top-level await works, and so let's now go straight to the next video. So now that you know how ES6 modules work, I just want to quickly show you the module pattern that we used to use before in order to implement modules in JavaScript. And I believe that it's important that you understand this module pattern because you will still see it around, and it's also a very good application of many of the stuff that we have been learning throughout the course. Now, of course, just like in regular modules that we just learned about, the main goal of the module pattern is to encapsulate functionality, to have private data, and to expose a public API. And the best way of achieving all that is by simply using a function, because functions give us private data by default and allow us to return values, which can become our public API. So let's see how the module pattern is implemented. So we start by writing a function. Okay, and usually we write an IFI, actually, so an immediately invoked function expression. And the reason for that is because this way we don't have to call it separately, and we can also ensure that it's only called once, right? And so for that, we wrap it like this and create an IFI. So it's very important that this function is only created once, because the goal of this function is not to reuse code by running it multiple times. The only purpose of this function is to create a new scope and return data just once. And then in here in the function, let's simply add the same variables that we had before in the other module. So let's do here again a shopping cart. And so in that other shopping cart, we had a bunch of private variables, basically, so data that was not exported. And so we simply defined them as variables there, and here we do the same thing in the function. So total price 237 and total quantity 23. We can also use our add to cart, and let's simply grab that from here. So without the export, of course. And in this one, let's actually add another very simple function, which will simply log something to the console. So this one is to order stock. So ordered from supplier, and let's call this one order stock. So right now, of course, all of this data here is private because it is inside of the scope of the function. And so now all we have to do is to return some of this stuff in order to basically return a public API. And so to do that, we simply return an object which contains the stuff that we want to make public here. So let's say, again, we want to add the add to cart function to the public API, also the cart array, and total price, and quantity. So basically, in this case, everything except the order stock. Okay? And of course, we could have also defined all of these here right in the object as properties and methods, but I find it a little bit cleaner to define everything outside and then to simply create an object which contains everything that we want to expose to the outside. However, right now we are not really storing this returned object here anywhere, right? So if we run this right now, then this object kind of disappears into nothing. However, that's easy to fix because we can simply assign the result of running this IFI here to a new variable. And so let's call this, just like before, the shopping cart. Let's say shopping cart 2. And so now, just like before, we can now say shopping cart 2 dot add to cart, and here let's say 4 apples and 2 pizzas. right? And so it works. And indeed, if we take a look at shopping cart, so shopping cart, now of course now it's not available here because we are still inside of a module. And everything that is in a module is private to that very module. And so therefore, we can now not access anything from this module here in the console, because this is here basically the global scope. But in the global scope, we are not creating any of this. So not even shopping cart 2, right? So again, that's because it is scoped only to this module. But let's still take a look at it here in the console. So of course, this we can do. And so here we see that indeed, we only exported these 4 things. Now, of course, our cart now got manipulated. So that one that we defined here in the function. Okay. But of course, on the other hand, the properties that we basically wanted to make private, they are not accessible. So we cannot do this, right? So they are undefined. All right. And that's actually it. That's the implementation of the module pattern. Now, do you understand exactly how and why this works? I mean, how do we, for example, have access to the cart variable here and even are able to manipulate it? So we see that it changed indeed. So how are we able to do that even if this iffy here, so this function has already returned long ago, right? So this function, of course, was only executed once in the beginning, and then all it did was to return this object and assigned it to this variable, right? But then we are able to use all of this and to also manipulate the data that is inside of this function, which is the function that returned this object. And the answer to how all of this works like this is, one more time, closures. So closures, remember, allow a function to have access to all the variables that were present at its birthplace, basically. So that was a nice analogy that I used back then when we first talked about closures, and I think it's a very nice way to visualize how it works also in this case. So the add2cart function was created here, right? And so this function here is the birthplace of this function. And so therefore, this function never loses connection to its birthplace, which was this function here. And so that birthplace, so to say, is all of this scope, which contains, of course, the cart. And so therefore, the add2cart function out here can still access that cart variable that was in the function. Okay? So the reason why this works is not because the cart variable is also in this object. So that's not relevant because here we are not using this.cart, right? We are simply using cart. So here we could also log something that is indeed private to this module. So something that will not be in this exported object. So let's say shipping cost is, and then shipping cost. And so in order to produce this string here, the function will also have to use this variable that was only present at its birthplace, but which no longer does exist besides that. So indeed, that still works. So the function is still able to access that value of 10. Okay? And for an even deeper explanation of why this works, you can of course always go back and revisit that lecture about closures. Okay, but in essence, again, this is how the module pattern works, and it works very well, and it has been working for a long time for developers. So long before ES6 modules even existed in JavaScript. Now the problem is that if we wanted one module per file, like we have with ES6 modules, then we would have to create different scripts and link all of them in the HTML file. And that then creates a couple of problems. Like we have to be careful with the order in which we declare them in HTML, and we would have all of the variables living in the global scope, and Finally, we also couldn't bundle them together using a module bundler. And so, as you learned at the beginning of this section, using a module bundler is very important in modern JavaScript. So the module pattern that we just learned about does indeed work quite good, but it has some limitations. And so that's exactly the reason why native modules were added to the language in ES6. Besides native ES modules and the module pattern, there are also other module systems that have been used by JavaScript in the past. But again, they were not native JavaScript, so they relied on some external implementations. And two examples are AMD modules and CommonJS modules. And in fact, CommonJS modules are worth taking a look at, and so let's do that now. Now, CommonJS modules are important for us because they have been used in Node.js for almost all of its existence. So only very recently, ES modules have actually been implemented in Node.js. And remember, Node.js is a way of running JavaScript on a web server outside of a browser. Now, the big consequence of this is that almost all the modules in the npm repository that we talked about in the beginning of this section, remember? So all these modules that we can use in our own code still use the CommonJS module system. And the reason for that is that npm was originally only intended for Node, which, as I said, uses CommonJS. Only later, npm became the standard repository for the whole JavaScript world. And so now we are basically stuck with CommonJS. And so therefore, you will see probably a lot of CommonJS still around. And so let's take a quick second to see what it looks like. So let's just pretend that we want to export something from this module. So let's get this function here again, like this. All right. And so just like ES6 modules, in CommonJS, one file is one module. Okay? And we export something from a module using export dot and then the name of the export. So let's say export dot add to cart and then whatever we want to export there. Now, of course, this is not going to work in the browser, but it would work in Node.js. Okay, so this export keyword here is basically an object that, again, is of course not defined here in our code and also not in the browser. But in Node.js, it is an important object that is used. Now, then to import something, let's just write this here. So export and import. And so this code is not for you to write. I just want to show this to you. So if we then wanted to import this, it would be pretty similar to ES modules actually. But then from here, we will call a require function. So just like this. All right. So again, require is of course not defined here in our browser environment, but it is defined in Node.js because this is part of the CommonJS specification. All right. And yeah, that's actually all I had to show you, even though this is of course just scratching the surface. But all I wanted to do here is to just let you know that there are different module systems and that CommonJS is particularly important in the world of JavaScript. Now, in the long run, ES6 modules will hopefully and probably replace all of these different module systems. But it's still going to be a long way until you're there, and so it's good that at least you know what this is when you stumble upon this syntax in the future in your work. Okay, and with this, let's move on to the rest of this section, where we will learn how to use third-party packages from npm, how to bundle all modules together, and also how to transpile our code back to ES5 for old browsers. Now, before we can use a tool like Parcel, we first need to learn a little bit about the command line. Yeah, you heard that right. All these build tools that are available on NPM only work in the command line. And so now comes that time where you finally have to learn a little bit about the basics, at least, of the command line. Now, if you already know this stuff, then please move on to the next lecture right away, because you will probably not learn anything new here. But for the rest of us, let's get started. So in this short video, all I want to do is to give you the foundation of the command line. So stuff like moving around in the file system, creating files and folders, copying files, and so on and so forth. Because as a web developer, it's really quite important that you know at least how to do these basic things using a terminal or a command prompt. Now, I know that many people are afraid of the command line for some reason. And actually, I'm the first to admit that I was afraid myself a long time ago. And I was always trying to just avoid it. But now I look back and, well, that's just silly. Because it's not hard at all. And now I can't live without the command line. And in fact, no serious web developer can live without the command line either. It's just part of the job. Alright? But enough talk, let's now actually do something. And we can go about this in different ways. So we can use a separate window. So on the Mac, I'm going to open up Terminal. Alright. Now, if you're on Windows, you can just right-click on the Start button and from there select the command prompt. So that's how the terminal is called on Windows. And if you're using Linux, well, then I'm pretty sure that you already know how to use the terminal and how to do all of this stuff. But anyways, this is only one of the ways of doing it. And many times as a web developer, you will use a separate window like this one. But since we're using VS Code already, and VS Code does have an integrated terminal, we can simply use that. So I will close that now and open up the terminal like this. And so here we go. Now here we see that we already have one terminal running. And so that's the one that is looking for changes here. So it's that node process, so that live server tool that we have been using. Okay. Now on Windows, it's not going to say bash here probably. And that's because the command line works a little bit different on Windows than it does on Unix-based systems like the Mac or Linux. But anyway, most commands are the same, and whenever one is different, I will let you know. Okay? Now, the first thing that you need to know about any command line is that you are always in a folder. So right now we are in this project folder, and so that's the beauty of VS Code. So whenever we open a terminal in VS Code, we are always in this project folder itself. And then from this location in the file system, we can move up and down using commands. Now the first command that I'm going to show you is ls, which on Windows is called dir, which stands for directory. So on Windows type dir, and on a Unix-based system ls. And so this will then show you the contents of the current folder. Alright, and so indeed, that's exactly the files that we have here, except for this one here, which starts with a dot. And so that's different, but never mind. Then the next command is cd, which stands for change directory. And with this, we can go up and down the file tree. For now, let's just go up, and for that, we use ... And so with this, we are now in the desktop. So let's take a look here as well. And so here we see all of the folders that we created before. Okay? And so let's now move into one of them. So I can write again cd. And then let's say I want to move into folder 13. So 13-advanced, but I actually don't have to type all of it. So instead, I can just hit the tab key, and it will then autocomplete this path for me. So that's very handy whenever we don't want to write everything by hand. So hit enter one more time, then ls or dir on Windows. And so with this, we can check out all the files that are in there. So again, 3 files, and then we also have a folder. So let's go there as well. So cd img, and again, let's check out what we have in there. So all of these images. All right, so let's move up. So that's ... again, and actually we want to move up 2 levels. And so here we can then add a slash, and then again, ... And so this will move up 2 levels back to the desktop. So here you see that we are at the desktop. Okay, then we can also clear the console like this. And so then everything disappears. Okay, let's take a look again. And remember one more time, it is dir on Windows. And so now let's actually go back to our project folder. And again, now I can already autocomplete because this part of the string is already unique. So I hit tab, enter, and then we are back in our project folder. So to clear this, I can again write clear, but in VS Code, I can also hit Command key, like this. Well, at least it works on Mac. I'm not sure about Windows. So you can also type clear like this. And so now let's actually here create a folder. So that's mkdir. And then let's simply call this test. And so if we check this out now, then here we have a new folder. And you can see that here as well. And of course, I could also see it here in the file system. Right, so there it is. And now back to VS Code actually. And let's move there now. Clear it again. And now here, let's just create some files. So for that, I'm using Touch on the Mac, and on Windows, it is Edit, like this. So let's say touch, and then index.html. And then let's also say script.js. Now these are empty files now, but we can still check them out here. And we could actually also call our live server here now. So we can say live server, and as always, I can autocomplete, hit enter, and then it will open up a new browser tab. And in this case, it didn't, because I'm using another browser. So let me finish this by writing Control-C, then clicking here and doing it again. And so I opened up this command again by clicking the up arrow, okay? And so now here it is. But let's cancel it again because we're not really interested in seeing this empty page. And so again, that is Control-C even on the Mac, so not Command-C. And here I can actually use the arrow key as many times as I want to see my past commands. And I can also go back down like this. So let's take a look again at the files we have. And we could also add multiple files all at once. And this is actually something pretty useful and that I do all the time when I need to create like multiple modules at once. So let's say jonas.js, let's say bankist.js, and mapty.js. And so now it created these 3 files all at once. I'm not sure why I wrote JS there, but never mind. Of course, JS does not exist, but here we now have all these files that we created previously. Okay? So we have all these files now, but we're not really interested in them, and so let's delete them. And for that, we can use rm on the Mac and del on Windows. So script.js, for example, and let's say also jonas.js. Let's take a look. And now we only have these 3 left. And let's say that we actually wanted to move one of them to the parent folder. So for that, we can use mv. Let's say we want mapty. And once again, I hit tab. And so we need to specify first the name of the file that should be moved, and then the location into which that file should be moved. So what is that location? Well, in this case, we want to move it to the parent folder. And so that is ... like this, and then the dash. Okay, And you actually already saw it appear here, right? And if we take a look here again, then there it is. If we move to that parent folder and check it out here as well, then there is mapty.js. All right. And so now we really don't need that test folder anymore. So let's delete that as well. And for that, we can use rmdir. So this stands for remove directory, while the opposite of that, remember, was mkdir. So make a directory. And so now we just need to specify that test. Oh, and the directory is not empty. So rmdir only works for empty directories, at least on the Mac. On Windows, I'm not sure how it works, but apparently on the Mac, only for empty directories. However, at least on the Mac, we can use another trick to remove a directory. So we can use again rm, which we also used to remove files, and then we can specify a flag. So that's basically an option which we write with a dash and then a specific symbol or letter. So in this case, that's R, which stands for recursive, and then the name of the directory. And so now it recursively basically deleted all the files that are in here, and then also the directory itself. And so as you see, that folder is now gone. All right. And again, on Windows, I'm not really sure about this one. Maybe rmdir just worked. But if not, well, if you really need it, then of course you can always go ahead and Google how it works on Windows as well. But with this, I think we actually covered everything that we needed. Let's just get rid of that mapty.js. So mapty.js, and again on Windows, that would be del for delete. Okay. And so with this, we are back to our initial working directory and can now keep going in this section. All right, so let's now finally use npm for the first time. And remember, npm stands for Node Package Manager, and it's both a software on our computer and a package repository. Now, before we jump straight into npm, let's start by understanding why we actually need something like npm. So why do we actually need a way of managing packages or dependencies in our project? Well, back in the day, before we had npm, we used to include external libraries right into our HTML. So basically using the script tag. And this would then expose a global variable that we could use. And actually, that's exactly what we did earlier in our mapty project. So let's actually use or open that here. So mapty and just the index.html file. And so here it is. And you see that indeed, we simply included the leaflet.js file basically using a script tag and did that before our own script, so that our own script could then use the global variable that was exposed by this library here, right? Remember that? Now, this actually creates a couple of problems, at least in a big project. So maybe not in this particular project that is really small, but in a huge project, in a huge team, this is just not manageable. First, it doesn't make much sense having the HTML loading all our JavaScript. That is just really messy. Also, many times we would actually download a library file to our computer directly. For example, a jQuery JavaScript file. But then, whenever a new version would come out, we would have to manually go to the site, download the new version, change the file in our file system manually, and then include it here again, maybe with some other name, with some other version number. And that was just a huge pain, believe me. And the third reason is that before npm, there simply wasn't a single repository that contained all the packages that we might need. And so this made it even worse and more difficult to manually download libraries and manage them on our computers. So in summary, this all used to be a huge pain and a huge mess. And maybe you even remember this yourself, like the old days of jQuery and dozens of jQuery plugins that you would have to keep updated. But anyway, all of this is just to say that we really need a way to manage our dependencies in a better and more modern way. And npm is exactly how we do that. And so let's start by using the npm software now. All right. So actually we will need this terminal now. So let me clear it. And we start by checking if we actually have npm installed. So to do that, just type npm-v. So this will check for the version. And if you get any number here, and it doesn't matter which one, then you're good. Well, in fact, it should actually be greater than 6. Okay, so anything that you have greater than 6 is good. But if you did get an error because you didn't install Node.js in one of the previous sections, then please go to this website now, so nodejs.org, and then download and install the version for your computer. So you can just use this LTS version. You don't have to go with the current one. And by the time you're watching this, LTS is probably already at 14 or 16 or 18, who knows, but that doesn't matter. So all that matters is that you install Node.js, and then as you run this command, you just need to get some number here, and then you're good to go. Now, in each project in which we want to use npm, we need to start by initializing it. And so for that, we write npm init, and this will then ask us a couple of questions in order to create a package.json file. So the questions are down here. So first the package name, and if we just hit enter, then whatever is here in these parentheses will be the default. And so for now we are just good with all of these defaults. So just keep pressing enter, and of course you could define things like the author, keywords, or whatever, but that doesn't really matter for now. So is this okay? Yes, it is. And then we end up with a special file called package.json, which is this one. So this is the file that npm just created for our project here. Now this file here is basically what stores the entire configuration of our project. So as you see, it's stuff like the project name itself, the version that we can keep on updating, and the author and all kinds of stuff. So for now, that's not really interesting, but it will be in a second. Okay, let's just close these files we don't need. This can become smaller, and let's also clear it. Okay, and now let's actually install the leaflet library that we used before, but this time using npm. So let's just search for the documentation page again. And so here I already showed it to you before, but let's take a look at it again. So here, using a JavaScript package manager, all we have to do is indeed npm install leaflet. And so this is how it will always work. So you write npm to run the npm program, then install, and then the name of the package. So leaflet like this, and then it will start downloading, and that's it. Now that way of installing it, so this one here was the long version, but we can also write just npm I and then leaflet like this. So that's going to be the same thing. And now you see that two things happened. So first of all, in our package.json file, a new field here was created for the dependencies. And the dependency that we have here now is leaflet that we just installed at version 1.6.0. Okay? And more about why this is important a little bit later again. But for now, let's take a look at the second thing that happened, which is that we now have this folder called Node modules. And this folder itself contains the leaflet folder, as you see here. All right. And so this is the code of this library. And here is some more code. But that is not really important. So you can take a look at it and you will see that it is like, 15,000 lines of code or something. And so this is not a small library by any means. Okay. And so, yeah, this folder contains everything about this library that we need to include in our page. And so, yeah, this folder simply contains everything about this package. And of course, the more packages we install, they will all get stored into the Node modules folder. Okay. So we installed our leaflet library now, but if we wanted to use it, that wouldn't be easy without a module bundler. And that's because this library actually uses the CommonJS module system. So for the reasons that I explained to you before. And so therefore, we cannot directly import it into our code. We could only do that if later we used a module bundler. But for now, we are not doing that. And so let's just not use leaflet for now. So this was just to show you how to install it. So instead, let me show you how we can install and import one of the most popular JavaScript libraries, which is Lodash. So Lodash like this. And Lodash is essentially a collection of a ton of useful functions for arrays, objects, functions, dates, and more. So it's a lot of like functions that could or should be included in JavaScript, but are not. And so people simply implemented them in Lodash, and so now we can use them. So down here we have the installation, and here you see again the old way of doing it as I explained it before. So that would be downloading it and then including it manually. Then here we have the npm way, but there also should be something else here I'm looking for. But here is how we actually install it using npm. So as always, npm install and then Lodash. However, I'm not looking for just the normal Lodash version because once again, that one actually uses CommonJS. And so we can't use CommonJS modules without a module bundler. And so I'm looking for a special version. And that one is called Lodash ES. And so ES is because of ES modules. All right. So here we say npm I for install and then Lodash dash ES. Then wait for it. And here it is in our dependencies. Let's take a look at it here as well. So here is Lodash. And so here we now basically have one file for each of the methods that are available in Lodash. And you see, it is a lot of them. Okay. And the one that I want to include now is the one for cloning objects. So that's called clonedeep.js. And so let's simply import it exactly like we used to do it. So import, and now let's check it out again, just to show you what the file looks like and how we can import it. So clone deep. So what matters here is that this uses export default clone deep. Okay, so it's a default export, and so we could give it any name that we want, but I will still just call it clone deep. And then, of course, from, and then the path. So node modules Lodash-ES, and thankfully VS Code is very helpful by showing us the path. Okay, let's see. And we get no errors here, which is already a good sign. Now, why did I actually include clone deep and not something else? Well, it's because I actually already mentioned Lodash before when we talked about copying objects. So remember that it's very hard to copy a nested object. So let's quickly create one here. because I think that this is pretty interesting. So let's say we have some card in here, and this itself is an array which itself contains some objects. So product, bread, and then quantity, let's say 5, and then pizza, let's say 5 again. And then we have a user which also has some object, let's say logged in true. So this is a deeply nested object, right? And so let's see what happens when we copy it using JavaScript. So state clone, and remember we use object.assign to create a copy of an object. And so we create an empty object, and then we basically merge that with the state. So let's take a look at the state clone. And so indeed, it looks exactly the same as the state, right? However, watch what happens when we change one of the nested objects in there. So when we now say state.user.loggedIn and set it to false, then see what happens to the logged in the copy. So you see that it is also false. And so that's for all the reasons that we already learned before. And so remember that back then I said that using Lodash would probably be a good idea instead of using object.assign. Because if we wanted to manually create a deep copy or a deep clone, well, that would be a lot of work. And so instead, we can simply use this function that Lodash gives us, so that some people already implemented for us, and which is also battle tested already. So clone deep state, and so watch what happens with this one. So again, this one here is the state clone, which of course now changed the logged into false. But this one, it's also false, but the reason for that is that we copied the object after we changed it. So that's just wrong, but now it should work. So again, this one changed to false, but this one now is still true, even though we changed it in the original object. Okay? And so this is a good solution for a deep clone that we just got from NPM. And that's great, right? So we just used a piece of open source software to solve a problem that we have sometimes in JavaScript. Great, that's just awesome. So again, you're now one step closer to working like a real JavaScript developer, because this is just what everyone does all the time. So this is the function that does the work, but actually it is this one here. But, well, let's not inspect it. But of course you can have some fun and take a look at how they implemented this. Okay? But I actually want to go back to this package.json file because it is actually very important. So let's say that you want to move your project to another computer, or also share it with another developer, or even check it into version control like Git. Now, in all of these scenarios, you should never ever include the node modules folder. So again, when you copy your project to somewhere else, there is no reason to include this huge node modules folder. Because in a real project, it will actually be really, really huge. So I have had folders here with tens of thousands of files. And so that will just slow you down, and it doesn't make much sense either, because all of these files, they are already at NPM, and so you can always get them back from there. But now you might ask, well, if I copy my project without the node modules folder, so without the dependencies, will I have to install all of them one by one? What if I have 20 or 200 dependencies? Well, that's again where this important package.json file comes into play. So let's actually simulate that by deleting this folder. So move to trash. And so now, of course, this does not work anymore. But there is fortunately a very easy way to get it back. All we have to do is npm and then install, or I, but just without any package name. And so then npm will reach into your package.json file, look at all the dependencies, and install them back. And so you see that our folder, well, it should be back. And yeah, so here it is, just like before. Okay, and so with this, you now have a basic, but I think good understanding of how to work with npm, downloading packages, and also include them in your code. However, importing packages like we did here, for example, by specifying this entire path, is not practical at all. And so in the next video, it's time to finally use Parcel to fix this. So the module bundler that we're going to use in this course is called Parcel. And it's super fast and easy to use. And even more importantly, it works out of the box without any configuration. Now, you might have heard of Webpack as well, which is probably the most popular bundler, and especially in React world. However, it's way too complex to use in a course like this, and so let's now learn how to use Parcel. So Parcel is basically just another build tool which is also on npm. And so we will use npm to install it. So npm install Parcel, but this is now a different dependency. And so here we have to write -- save dev like this. Okay, then hit enter and simply watch it install. So a dev dependency is basically like a tool that we need to build our application. But it's not a dependency that we actually include in our code. All right, so it's simply a tool, and so that's why it's called a dev dependency, because we can use it to develop our project. And so therefore it appears here in a new field in our package.json file. So again, these libraries that we actually include in our code are the regular dependencies, and Parcel is a dev dependency. All right, so let's clear the console here and actually use Parcel. So we do it here in the terminal because Parcel is basically just another command line interface. However, we cannot simply run Parcel like this. So this is not going to work because the command is not found. And the reason for that is simply that this doesn't work with locally installed packages. And Parcel was indeed installed locally, so basically only on this project, and that's why it showed up in the package.json file of this exact project. So there are also global installations, but more about that by the end of this video. Now, in order to still be able to use Parcel here in the console, we have two options. So we can use something called npx, or we can use npm scripts. So let's start with npx, which is basically an application built into npm. So the details don't matter, but what does matter is that we can simply use npx to now run the same command as we did before, but this time it is going to work. And so this is the normal command, and the option that we pass into Parcel basically is this entry point. So the entry point is index.html because that is where we include our script.js. So basically the file that we want to bundle up. So in our script.js, we are currently including this clone deep module from Lodash. And also let's actually put back this code from the beginning so that we are also importing our shopping cart module from before. And so basically in this example, the goal of using Parcel is to bundle these three modules together. So script.js together with shoppingcart.js and together with this clone deep. And so let's actually try this now. So I'm hitting enter here, and now it's going to take some time and do some magic behind the scenes, but now it is actually done. So Parcel actually then also starts a new development server on this URL. So let's click that. And so you see it opened a new tab right here. So basically, besides only bundling, it also does exactly the same job as our live server. So remember that we started this development server using the live server package, right? And so this one here does exactly the same. The difference is that this one is on port 8080 and this one is on port 1234. And here we also have localhost, but that is exactly the same as writing 127.0.0.1. So this is just the raw IP address and localhost is the nicer name. All right. Now, if you did have any errors by doing this, so maybe you couldn't even install Parcel, or maybe you got some error while you were trying to run this command, then let me help you troubleshoot that. So to do that, I'm going to open a new terminal here, and we can do that by clicking this plus. And so now we have 3. And this first one we actually don't need anymore. So this one is still running our live server. And so let's cancel that by hitting Control-C. Okay? And again, that's because Parcel already does that same job. And so right now, we no longer need this. And so now it's not working anymore. So let's close it. And the same for this terminal window. But anyway, let's go back to the one we were using. And so again, if you had any error installing it, you can try installing it with sudo, which will give you basically more permissions. So you write sudo and then exactly the same command as before. So npm install Parcel. This will then ask you for your password, and then hopefully that's going to work. Now, if that doesn't fix it, then you have to install exactly the same version as I am using here. So we can read that in our package.json file. And so here you see that I'm using version 1.12.4. And so you can npm install exactly this version by writing @ and then 1.12.4. So maybe you have version 2 already installed because it's going to be coming out very soon, and then that might break something. And so therefore it's best to use this version 1.12.4, at least in this project. In the next project, we will probably use version 2. And if that still doesn't fix it, then before doing this command, you can try to uninstall it first. So npm uninstall Parcel like this, and then after that, you can try again to install this version. And so then you should be good to go. So you should have no more errors then. Okay. Now, speaking of errors, we do actually have one error here coming from our code. But the problem of that is that we still have this type module here. However, what Parcel does is that it basically simply creates a script. And so now we are actually no longer using a module, but we are back to using a regular script. And that is important because modules do not work in older browsers. So let's comment this one out just so we can also keep it. Then I'm deleting this part, and then let's give it a save so that Parcel can rebuild this application. And great, the error is gone. Okay, but now let's actually take a look at what Parcel did here. So what it did was to create this dist folder, which stands for distribution, because it is essentially going to be this folder that we will send for production. So basically it's the code in this folder that we will send to our final users. So you see it created a new index.html here and also a bunch of JavaScript files. So let's take a look at this index here. And so you see that indeed it is a new one, because the included script here is now no longer the one that we built ourselves, but it is script dot and then all of this here. And so this new script here is basically the bundle itself. So it's this file, and so let's analyze it here as well. Okay, and so here you already see that it does include some of the stuff that we have in our other modules. So importing module, for example, we had in script.js. Let's see what else we have here. So here you see a bunch of stuff that is created by Parcel, of course. So this is basically the clone deep function probably at some point here. So you see a lot of code created by Parcel. But yeah, so in the real world, you will not take a look at this code. But I just wanted to show you that, of course, all of our code is now in here. So let's just search for clone deep, for example. So the one that we used. And so it's got to be somewhere down here as a function. And so indeed, all the code that we had before spread across multiple modules is now all in this script. And so that's exactly the goal that we had. And unused code has probably also not yet been removed, but we will leave that for later. So that's going to be the build step. But what we're doing right now is the development step. And so in order for us to be able to check the code during development, it will not compress everything. All right, so we can close all of this and go back to our script here because I want to show you something. So of course, whenever we now save this file, then it will reload this file here just as we had before with live server, right? So as I saved, you see that everything here reloaded, right? And we can see that here as well. So take a look at what happens when I save this here. Then you see this happened again. However, in Parcel, we can activate something even better, which is called hot module replacement. So we can write if module.hot like this, then module.hot.accept. Now this code here is code that only Parcel understands, and so of course it will not make it into our final bundle because the browser is not going to understand any of it. But anyway, what hot module reloading means is that whenever we change one of the modules, it will then of course trigger a rebuild like this, but that new modified bundle will then automatically, like magic, get injected into the browser without triggering a whole page reload. All right. So again, whenever we change something here, this will then not reload this part of the page. And so that's going to be amazing for maintaining state on our page whenever we are testing out something. So this used to be something quite annoying in the past. For example, in our Bankist application, where whenever we reloaded the page, we needed to log in again into the application. Remember that? But with Parcel and hot module replacement, that's not going to happen because the page will not reload. So if I save this now, then probably it's going to look the same. But again, if we had some state here on the page, then that would be maintained. Okay, next up, let's change something here. So as I said, when we first included this clone deep here from Lodash, this is quite cumbersome doing it like this. And so that's why in all module bundlers, there's no need for specifying the entire path to any module. So instead, we can simply do this. So keeping this here just for reference. And then all we need to say is that we want to include the Lodash library. And so Parcel will then automatically find the path to this module and will simply import it like this without us having to manually type the entire path to there. And so that's a lot more useful than what we had before. And in fact, this works with all kinds of assets. So even with HTML or CSS or SAS files or even images, and of course also all kinds of modules. So not only ES6 modules, but this is also going to work with common JS modules. So let me actually show that to you. So instead of importing the ES version of Lodash, we can simply import Lodash like this. So just the regular version of Lodash. And Parcel is even smart enough to then automatically install this package here. Okay, so now if we go to our package.json right here, well, it's probably not here, so it looks like maybe it didn't install it, so probably it's simply still using this one. Okay, but anyway, what I said is still true, so Parcel can indeed work with all common JS modules as well. And so this way, we can then simply use all the modules that are available on NPM and which still use this older module format. So let's leave it like this, save it again, and maybe you have been noticing that this card array here keeps growing and growing and growing. So if we take a look at this, you see that we are adding these 3 products over and over again. And so the reason for that is hot module replacement. So the state is maintained whenever we reload the page here. And so that's exactly what we can now observe here. Okay, so if we save it again, then we will have 15. Because we are simply adding new objects into this object that keeps persisting over page reloads, basically. And so this works with all state. And again, it's going to be really, really helpful. Okay, so this is how Parcel works. Let me now finish it here, because remember, the way we executed Parcel first was by saying npx parcel and then index.html. However, I mentioned that there is a second way, which is to use npm scripts. And so that's the way we actually use it in practice. So npm scripts are basically another way of running locally installed packages in the command line. They also allow us to basically automate repetitive tasks. And so therefore we then don't have to write npx, parcel and all of that every time that we want to use it. So we can simply create a script here. Let me delete this one here. Let me just delete all of it and create a new one. So we need double quotes and then the name of the script. And the default is start here. And then here comes the script itself. And so the script is going to be simply parcel index.html. So again, we can't write this command directly in the command line, but we can write it in the npm script. And so let's now go back to our console and try it out and actually run this command. npm run and then start. And so start is the name of the npm script that we defined here. So let's try that, and here we go. So it's doing the same thing as before, but now we have the simple command that we can execute whenever we want to start Parcel and whenever we want to start developing, basically. All right, and so again, that is mainly how we do it in development. Okay, and speaking of development, whenever we are done developing our project, it is time to build the final bundle. So the bundle that is compressed and has dead code elimination and all of that. And so for that, we need another parcel command. And so let's add that as another script here. So we need a comma, and then this one will be called build. And so parcel build, and then again index.html. So let's stop this one here actually. And now let's run npm run a build. So this might take some more time this time because it's doing a lot more work behind the scenes, but let's just wait for it. All right. And so now we even get this nice output with the sizes of everything. And so let's now take a look at our dist folder. And you see immediately that this HTML looks different, right? It is compressed now. So the script that we can then ship to the browser and ship to our users is this one. So ending in FD3. So this one. All right. And again, you see that it looks quite different. Everything is compressed into this unreadable mess, but it is, of course, a lot more performant than the script that we had before. And so that's why Parcel does this for us. And we will again come back to all of this in the real world once we actually move to our next more real project in which we're going to use all of this. Now, just to finish this lecture, I also wanted to mention that we can also install packages globally. And so that would work like this. So npm install parcel and then G, which stands for global. And this is actually the way that we installed the live server package before. And so because of that, we were then simply able to use live server in every directory on our computer. So basically the big difference between globally and locally installed packages, and especially these tools like Parcel or live server, is that we can use the global tools directly in the command line without the intermediate step of an npm script. However, most of these tools actually advise developers to always install the tools locally so that they can always stay on the latest version. And so usually I follow that approach as well. And so I'm not going to install Parcel globally like this. Okay, and that's the fundamentals of bundling with Parcel and of using build tools with npm. So I introduced a lot of different concepts here. So to make sure to review this, especially this part about the npm scripts, maybe that might be confusing, and also take a look at the output files that Parcel gives us. So just take some time to review all that we did in this video, and if after that this is all still very confusing to you, then don't worry. I'm sure that it will make total sense once we actually use this in our next big project. Now that we activated bundling, it's time to configure Babel to transpile or super modern code back to ES5 code. And this is still important right now, even many years after the new ES6 standard has been introduced. And the reason for that is simply that there are still many people out there who are stuck on like a Windows XP or Windows 7 computer and who cannot upgrade their old Internet Explorers. But we want our applications to work for everyone, and so we need to keep everyone in mind. Now the good news is that Parcel actually automatically uses Babel to transpile our code. And we can configure Babel a lot if we want to, for example defining exactly what browsers should be supported. But as always, that's a ton of work, and so we don't want that, and instead Parcel makes some very good default decisions for us, and so we will simply mainly just go with these defaults. Now just so you get a very broad and very general overview of how Babel works, let's just take a look at their website. So that's babeljs.io, and then here in the documentation, let's take a look here at plugins. Okay. So basically Babel works with plugins and presets that can both be configured. Now a plugin is basically a specific JavaScript feature that we want to transpile, so to convert. So for example, let's say we only want to convert arrow functions back to ES5, but leave everything else in ES6. For example, const and var declarations. Now usually that doesn't make a lot of sense, because basically we will want to transpile everything at the same time. And so usually instead of using single plugins for each of these features, Babel actually uses presets. And so a preset is basically a bunch of plugins bundled together. And by default, Parcel is going to use this preset env preset here. And this preset will automatically select which JavaScript features should be compiled based on browser support. And again, that will all happen automatically. And out of the box, Babel will convert all features, so only browsers that are barely used anymore with a market share of less than 0.25% are not going to be supported by the transpiling with this preset here. So that's just a very brief overview, and we will come back here in a second. But for now, let's start or npm run start script again, just so we can take a look again at our final output. So the one we have right now, or we had before, was the compressed one, which was not really helpful. And so now the script is at this one, so F30. So this one, and we can see right away that ES6 is no longer there. So here we have var instead of const that we had before. Let's see if we have something else. So here we used to have a template literal, I believe. And this was now converted to, again, regular ES5 code by using this concat method. So everything that we used from ES6 is now gone. But now let me show you something important. So let's write some code here, which is basically not part of this preset here, because this preset env does actually only include final features. So features that are already part of the language after passing the 4 stages of the ECMA process. However, previously we used class fields, which at the time of recording are only at stage 3. And so let me show you how we could transpile class fields as well. So let's just write a simple example here. And so here I'm going to use a field called greeting, which I'm going to set to hey, and then just a normal constructor which takes a name, this.name equals the name. And then as the constructor is run, it will simply log to the console this.greeting and then the name. So like, hey, Jonas. So const Jonas is a new person, Jonas. But now let's see what happens here. And we should get some kind of error. So let's see. Oh, and apparently it does work now. When I last tested it, it didn't work. So let's make this private. Maybe then we get the error I was expecting. But actually no, everything is working great. Let me just search our code here for person. And so here you can see that the person class has nicely been converted to ES5. So the class keyword is nowhere to be found anymore. And then our entire code that we had here was basically converted to this. All right. And so therefore, there is actually no more need for what I was going to show you, which we had to do before, which was to include this plugin here for the class properties. Because this is still an experimental feature. And so, yeah, we had to manually include this plugin here in order to make this code work. But now that's no longer necessary. And so that makes this even more amazing. But let's try another experimental one. For example, this nullish coalescing operator, which is still also a bit more on the experimental side. So let's say Jonas or null, let's say. And so that actually works as well. Okay, great. Now, there's still 2 more things that I need to show you here still. And so let's write some more code here. So what I will do now is to use the ES6 find method to find products in a cart that are added more than twice. So that's, I believe, just cart. So cart dot find, because remember, this is an ES6 method. And then return dot quantity where it's greater or equal to. And so that is only the pizza here. So you see, well, maybe this isn't a cart. Let's see what's happening. Oh, but never mind. This is not filter, it is just find. So it will simply find the first element, right? And so this is the first element where the quantity is greater to. But anyway, what I want to show you here is that, well, let me show it to you actually first. So to find this code here in this other script, I will copy this part and then put it here. And so you see that here is basically that same code. So the arrow function that we had is gone, and it was replaced by this regular function. However, the ES6 method find is still here. So it has not been converted to ES5. And the same is true for other things. For example, let's try promises. So promise dot resolve. So we're creating an immediately resolved promise. To make this really a quick example, then let's just log X to the console. And so that works, but it works because our browser understands ES6. Because if we take a look here now, then promise is also not converted to ES5. So remember, promise is an ES6 feature, but again, it was not converted back to ES5. And the reason for that is that Babel can actually only transpile ES6 syntax. So that's things like arrow functions, classes, const, or the spread operator. So these are basically things that have an equivalent way of writing them in ES5. So for example, the arrow function, it is simply a different syntax. And so Babel can simply write function instead of that. And the same goes with const. So it's very easy to simply convert that to var. But the same is not true for real new features that were added to the language, like find and promise. So these new additions to the language, so these new features, they can simply not be transpiled. It's simply not possible. Only syntax is easy to convert, so easy to compile. However, all hope is not lost. So for these added features, again, such as promises or all the array methods like find, and really a bunch of other stuff, we can polyfill them. And so that's why, since the beginning, I've always been saying transpiling and polyfilling. So these new features, we have to polyfill them. Now, Babel used to do polyfilling out of the box some time ago, but recently they started to simply recommending another library. And so we now have to manually import that as well. So import core.js. So that's the name of the library. And then we usually only want to import a part of that library. And that's called stable. And so we can write this. Okay. Now, usually we have to install all of the packages first, but fortunately Parcel is smart enough to install this automatically. Well, at least that is how it should be. So maybe that doesn't work after all. So let's manually install it, but that's weird. So core.js. So let's see. And so here we go. So let's resave it. And so here we go. Okay. So you should probably also try to install core.js manually, and then you will be able to use it like this. So maybe you're starting to see that these things really change all the time. And so I am even confused myself sometimes on why certain things used to work and now they work differently. But the good thing is that you don't really have to understand all this. So this is really more like a recipe that you just need to follow. And then with time, it will all become like a routine and it will become simple. But anyway, let's go back to our code. But you will notice that the code we had before is actually still there. So it's still the same, and promise and find have not been replaced. And that's because that's simply not the way it's supposed to work. So instead, what polyfilling does is to basically recreate the find function and make it available in this bundle so that the code can then use it. So let's search for array.prototype, which remember is where all the array methods are put. So array.prototype.find, and so, well, here it is. So Babel then uses this weird create method, but what matters here is that this will basically implement array prototype find. And the same for find index, every, sum, filter, map, and also for each. Even though these last ones here are not ES6, but for some reason they're still polyfilled here. All right, and the same for promise, probably. Well, not probably, for sure. Otherwise, this is not going to work. And it's not easy to find it, but, well, here is the definition of promise, which is going to be global promise. But I'm not going to dig even deeper into this. That's just not really necessary. However, as you just saw before, the polyfilling is going to polyfill everything, even if we don't need it. So we had the find index method there as well. Let's actually go back there. So array.prototype.find. So it also created find index and every and sum. And so we are actually not even using these. And so if we wanted, we could cherry pick basically just the features that we actually want to polyfill. Now that, of course, is a lot of work, but it will also greatly reduce the bundle size. And so it might be worth it if that's really a concern. So we could, instead of this, so instead of basically importing everything there is, we can just say core.js stable and then only array and then find like this. And so now if we go back here, then, well, then only this one should be here. And yeah, it looks different now. And so probably only this one was now polyfilled. And the same you could do for promise. Like this. Okay? So that's going to be a lot of work, which we usually don't do, but it is possible, again, if you are really worried about your bundle size. Finally, just to finish, there is still one feature that is not polyfilled by this one here. And so we always need to install just one more package, which is called npm install regenerator runtime. So regenerator, that's correct. So let's see. Let's already include it here. So we need import, so regenerator runtime, and then slash runtime like this. All right. So this here is for polyfilling async functions. So again, it probably looks a bit confusing that we have to do all of this, but yeah, don't worry. It's just a recipe that you have to follow. Okay. And usually you would put these imports here right at the top of your file. But in this case, we can just leave them here because they will be hoisted anyway, right? Also keep in mind that all of this might change. And so if you're watching this video like in 2 years from now, then things might be different and things might not work the same. And so once again, make sure that you then install exactly the same versions as I have here. Especially this core.js and regenerator runtime. And of course, also parcel. So just as I told you in the last video. Okay, and with this, we're actually done with this video and also with learning about modern JavaScript development. So basically, with learning about tooling such as Parcel and Babel, and also about modules. Now, in the remainder of this section, so the next two videos, we will just quickly also talk about modern JavaScript coding. So more on the actual programming side of things. And so there we will learn, or actually more review, how to write clean and modern JavaScript code. So in this section, we have talked about modern JavaScript development practices, such as tooling and modules. Now, since this is a section about how to write modern JavaScript, let's actually finish the section by reviewing clean and modern JavaScript coding style, and also take a brief look at some functional JavaScript principles in the next video. And this lecture is actually mostly going to be a review lecture. So a lecture where I'm going to bring together all the clean and modern JavaScript techniques and practices that I've been showing you throughout the course. And so with this, you will then have all this information in one place. Then in the next lecture, we will actually bring some of these topics to practice by fixing a bad coding example that does not follow these practices. But anyway, let's now get started. So one of the most important things when you code is that you should write readable code, which basically means that you should write code so that others can understand it, and also so that you can understand it yourself in the future. Also, you should try to avoid writing too clever and maybe overcomplicated solutions that might make you feel really smart as a developer, but which also might make your code very confusing and unreadable. And so in many situations, it's best to simply write the most straightforward solutions. Another thing that's very important for readable code is to give functions and variables very descriptive names. So for variables, you should name them according to what they contain, and for functions, you should name them according to what they do. And so by doing this, you will make it really clear and obvious to everyone what each variable is and what each function does. Next, there are some more general rules that you should follow in order to write modern and clean code, which are to use the dry principle, so don't repeat yourself, which means that you should essentially refactor your code whenever you can. Also, you should not pollute the global namespace and instead encapsulate your data into functions or classes or modules. Also, you shouldn't use var for declaring variables, right? So I've mentioned this one many times in the course, and so by now you already know that you should always use const, and only if you want to change any variable, then use let, but never var. And finally, you should always use strong type checks. So always use the triple equals over the simple double equals, which do not perform type checks. Now, about writing functions, which is one of the most important things that we do as JavaScript developers, the main rule that we should follow by writing functions is that each function should usually only do one thing. All right? Now, many times, of course, we will want to break that rule, but in general, it's good to keep this rule in mind so that you always write like small functions which only do one thing, but do it really well. All right? Next, you shouldn't use more than 3 parameters in a function. And this actually goes in line with the previous guideline because, of course, if a function only does one thing, then probably it doesn't need so many parameters in the first place. Also, use default parameters in your functions whenever that's possible, and in general, return the same data type as you received. So for example, if you receive 2 or 3 numbers as an input to a function, then probably you will want to return a number as well. So that then makes more sense for when you consume, so for when you use the function later. And again, this is a rule that you can of course break, but it's again good to keep this one in mind. Finally, you can and should use arrow functions whenever they make the code more readable. Okay? And here, many people actually have different opinions. So some people started to use arrow functions everywhere, and some people don't like them at all because they think that they completely make code unreadable no matter when they're used. But personally, I like to kind of follow a middle ground. So I still use the more regular functions in many situations, but if arrow functions make the code more readable, then I will totally use arrow functions. And one great use case, in my opinion, is in the callback functions of array methods. And now, after functions, our next topic is object-oriented programming. And in my opinion, in order to implement OOP in JavaScript, you should now use ES6 classes. And so that's also what I did after our OOP section, right? Now, when designing your classes, make sure that you encapsulate any data that shouldn't be accessible from the outside so that you don't mutate that data from outside the class. All right. Now, probably you will still need to at least manipulate some data that's in the class, but for that, you should then implement a public API, so basically a couple of methods that can then manipulate that data exactly as you want that to happen. And again, we talked about all of this already before. So this is really just a review of all these big topics that we have been handling throughout all of this course. Now, as you implement your methods in your classes, make sure that you implement chaining in all the methods where it actually makes sense, because this can make your methods way easier to use, not only for you, but maybe also for other developers on your team. So this is yet another great practice when you are writing your classes. Finally, one important thing to also mention here is that in regular objects, when you're writing methods, then please don't use the arrow functions there, because by doing that, you will not get access to the this keyword of that object. Remember? And so always avoid arrow functions, even if you're not even using the this keyword in a method, because simply by getting into the habit of avoiding arrow functions as methods in this situation, you will then not commit any mistakes ever. All right? Okay. Next up, let's talk about avoiding nested code. So writing nested code, which basically means writing code inside of blocks, inside of other blocks, is really, really bad for readable code. And so we should avoid nested code at all costs. And one great way of avoiding nested code is to use guard clauses, as we have been doing over the last couple of sections, right? So guard clauses basically simply means to use an early return in case some condition is not met. Also, you can use the ternary operator or even logical operators instead of an if statement, because the ternary operator, of course, does not create a new code block, while the if statement does. Now, if you really do need an if statement, then instead of an if-else statement, you should use multiple ifs instead, because again, this will make code a lot more readable than having to go through all these if and else if and else blocks. So that's also another modern practice that we start to see more and more in modern JavaScript code bases. Next, you should completely avoid any kind of loops. And with that, I mean any for loops. So the for and also the for off loops should be avoided if you want to avoid nested code. And so instead, you can use array methods like map, filter, and reduce. And finally, you should avoid callback-based asynchronous APIs whenever you can. And so that actually brings us to our next topic, which is asynchronous code. So for best readability, always consume promises using async await and not using the then and the catch methods. because these methods actually require callback functions, which will then introduce even more nested code. And so that's, again, something that we really want to avoid. All right, so these two go kind of together. So avoiding callback-based asynchronous APIs and instead opting for using promises and then consume these promises with async await. Now, something that's very important is that whenever you can, you should run promises in parallel using the promise.all combinator function. So when you have two promises that can run at the same time, so promises that do not depend on each other, then please run them in parallel to make the application a little bit faster for your users. And finally, always handle errors and promise rejections. So this is simply a best practice for clean code. All right, so these are the main best practices for writing modern and clean JavaScript code that I can think of. And so let's now put some of these guidelines that I gave you for clean and modern code in practice. All right, so let's now take a look at some bad code that doesn't follow any of the principles or guidelines that I showed you in the previous lecture and actually start fixing it in this video. And the code that we're going to fix is also here in your starter files, and it is called clean.js. All right. Now let's open up our console back here because it is still running parcel from before. And so let's stop that now. So with Control C, and then let's also come to our index.html file. And then here, let's copy this because now we no longer want to include script.js. So I will comment it out, but instead we want clean.js that we will work on now. So give it a save. And now we will also run this code again with live server and no longer with parcel, because now there's nothing to bundle. All we want to do is to take a look at our code in a very simple way. So live server, and let me grab that tab from another browser that I have opened. And here we go. So you see indeed that the URL is different here because the default URL of live server is 8080. So as you see here, and of parcel, it is on port 1234. So it's different. So we are not interested in this one anymore, but instead in 8080. So we can close this one as well, and our sidebar too. So let's reload this here so we can see our results. Make it a bit bigger as well. And okay, let's start by analyzing here our clean code, or actually the not so clean code that we want to start fixing in this lecture. So this code is basically about a very, very simple budget application, let's say. And so here we have an object which is called budget, which contains a couple of objects. So each of them is basically an entry in the budget. So each one has a value, a description, and a user of the person who created the entry. So this one is Jonas, this one as well. And you see that here we have a negative value, which is basically an expense. So for groceries, for example, and here the positive one is for an income, like selling an old TV or monthly salary or freelancing. So we have Jonas, and then the other user that we have here is Matilda. Then down here we have a very simple object, which is basically spending limits. So Jonas can only spend 1,500 euros or dollars or whatever it is, and Matilda can only spend 100. Then we have a function to add a new entry to the budget, or actually this one is only for expenses. And so here we start seeing one of the bad practices, which is that this function name is not good at all. So it's not really descriptive of what's happening here. And so let's actually start by fixing that right away. So this one should be called add expense. So you see I'm changing it here, and I selected all of them by hitting Command D. So add next occurrence, right? So that's the first fix, but of course there are going to be some more. But let's keep going through our code here very quickly. And so next up, we have a check function, which will basically check the budget and see if any of the expenses are actually above the limit that we defined here. And if a certain expense is, then it will flag that by adding a limit string to a new flag property on the budget entry. All right. So this add expense here actually checks if the new expense is below the limit. So that happens right here. But there might already be an expense that is below the limit, or actually over the limit, which is like this one here. So 1800, if we don't consider the minus. So I spent 1800 here, and that of course is more than 1500. And so this one would be marked as a limit. Okay, but again, we will see this in detail once we fix the code in each of them. Then finally, we also have one function which will log all the big expenses. So we can pass in a limit, and then it will go through all the expenses and log the big ones in a certain way. And let's actually call that function here. And let's say 1000. And so it then prints only the emoji of all the expenses that were more expensive than 1000. All right. And so let's now fix all of this, and starting with the var keyword here. So as we learned in the last lecture, we should always use const or let instead of var. So I will select all of them by clicking or hitting Command D and change them to const, even though there is one that should not be a const, which is this one here. So when we don't need a const, then we should use let. And we will see why that is here in a minute. All right, so that was the first fix. Then this one here, the name limits isn't really meaningful, so let's call it spending limits. So again, selecting it everywhere, and then spending limits. And so this makes the code more readable and more understandable, especially if we look at it in the future. Now we have some problem in line 39. So it's the same problem as before. It should also be a let. And then line 59. Yeah, here it should also be a let. Okay, now everything works as before. Here we already changed the function name to add expense as before. Then here we have these parameter names, which actually make sense. So these are fine, no need to change anything here. Then next up we have this check. So what happens here? So if there's no user, then set the user to Jonas. Now, what does this actually mean? Well, essentially, this is like setting a default parameter, right? So again, if the user is not set, as we're checking here, then it should be set to Jonas. And let's confirm that that actually happens here. And so indeed here, when pizza is added without the third argument, which is user, then it is automatically set to Jonas. But again, as we learned in the last lecture, whenever possible, we should use the native language features. So in this case, the default parameters. So that's as simple as this. And if we now check it again, then yeah, it is still Jonas. Nice. Okay. Next up, let's fix this ugly nested code here. So this code looks like it was written by a complete beginner And so we want to avoid that, right? So instead of using this nested code and this huge if-else statement with all of these blocks here, let's instead use a nice and declarative ternary operator. So let's actually call it limit, because lim, again, is not really a nice variable name. It's not really descriptive, right? So to do this, let's first analyze what actually happens here. So the function, of course, receives a user, and then here we check if there is actually a property with the name of user in spending limits. So for example, with the default argument here, Jonas, then of course there is spending limits.jonas. And so then in this case, the limit will be set to that value, so 1500. Okay, and otherwise, if that name does not exist, then the limit will be 0. And so therefore, then here in this check, the expense will not be added. So if the value is less than the limit, then the expense will not be added. And so therefore, we are setting the limit to 0 if the name does not exist. So if someone else, like J here, is trying to add a new expense, then the limit of J will be 0. And so therefore, he will not be able to add any expense, right? So basically here we can do just what we do here. So we can basically just do what we do here. So check if this exists, and if it does, then we return it, and otherwise we just return 0. So we can now delete this. And of course, here finally, we can change it to a limit. And yeah, so our code here still works the same. We still get pizza added and going to movies for Matilda, which has a value of -100. And a bit more about that in a second. Now, if we try to add a value for Matilda which is greater than 100, let's say 110, then you immediately see that it was not added. So now the last one that we have here is pizza. Okay, and the same here for J. So again, J is not in the spending limits, therefore his limit is 0, and then that means that his expense is not going to be added. Okay. Now, this one here works just fine, but we could make it even more clever if we wanted. So let me show you another way of doing the same thing. And I said in the last lecture that we shouldn't write too clever code, at least if we then cannot understand it. But the one I'm going to show you here is actually not too bad. So what we're going to do here is to use optional chaining. So optional chaining, remember, works like this. But we can even use it with bracket notations. So here we can then ask for the user property again. And so, as we learned before, if there is a property with this name, for example, Jonas here, then all of this here will be that value. But if not, then it will be undefined. So in that case, we then want to set it to 0. And for that, we can use the nullish coalescing operator, which was introduced in ES 2020 at the same time as this one here, so as optional chaining. And these are actually huge additions to the language. They're used all the time, and so it's a good idea that you get used to writing code like this. All right, so let's see. And our result should be exactly the same, and indeed it is. Great, so I think that this one here is even better. So in case that the value is indeed below the limit, then a new object is created like this and will then be pushed to this budget array. That makes sense, right? Now the value here will then be the value but negative. So you see here that all our expenses are negative values and the incomes are positive. And since we're adding an expense, it should indeed be negative. Now here we can actually improve our code a little bit because we have description equal description and user equal user. But that's not necessary, right? Because with the enhanced object literal syntax, we don't need to repeat that. So if the property name is the same as the variable name, we can simply do this and our result will still be the same. Great. So with this, our code already looks a lot more professional than it did in the beginning, right? But anyway, let's move on here to the next one. And so, as I said in the beginning, what this function here does is to check all of the expenses and see if none of them exceeds the spending limit. So the name here is, again, not ideal. So let's actually call it check expenses. And so what this function does is it loops over all of the entries of the budget like this. And here it's simply called like L for element. So let's change that to entry. So a budget entry, that makes a bit more sense. And then here, again, we get that spending limit from the spending limits object. Now here, of course, we don't have any user passed in, but the username is simply gotten from each of the current budget entries, right? And if any of this is a bit confusing to you, then please just pause the video and analyze the code a bit better for yourself. So that's not really the point of this video. The point of this one is more to fix the code, so to make it more clean and especially more modern. So you see that this code that we have here is very similar to the one that we had before. So here in this function. So let's just copy this and put that here. And then here it is entry.user. And yeah, then we can get rid of all of this. And here we need to go back to calling it limit. And let's see what happens then. So here we have this bigger expense. So it's over the 1500 limit. And so indeed, now we get a new property here, flag set to limit, just as we have it here. There should be another one somewhere. I think for Matilda, because she has the limit of 100, but these toys were 125. And so this one also has the limit flag. So flag set to the string of limit. So that still works nice. We can just improve this a little bit more because this code is now essentially the same as this one. So remember the dry principle. So we should not repeat ourselves. And so what I'm going to do is to refactor this code into its own function, which I'm going to call get limit. And for these simpler functions, I like to use a simple arrow function. So it's going to take a user, and here, of course, it's not the arrow yet. So it takes a user and then it basically just returns this. Right? And so here the limit is going to be get limit for the user. And then down here, the same. And let's actually put that right here. So get limit, and remember it here, it is entry.user. Then we can get rid of this. And because now we can actually get rid of the block entirely, because now the only thing that we have in the loop is just this one declaration. So we don't need these ugly braces anymore. And the same actually here. All right, so that's a bit better. And in fact, we will keep improving this after the next lecture, when we will basically make this whole code here a little bit more functional and more declarative. But for now, this is already a lot better than what we had initially. And here actually we can do the same. Take that, put it here. and then just like this. Let's just check again if everything is correct. And indeed, it is still flagged with the limit. Okay, nice. We can get rid of this one here. Let's actually put all of the logs at the end. And now finally, we have the big expenses function, which will basically simply log to the console this string here. And so let's improve the name here a little bit and set it to log big expenses. So that's a little bit better. And here this limit now seems a little bit as if it is the spending limit of before, but it's really not. It's just like an arbitrary limit that we pass in just to see expenses that are bigger than this value. So let's just call this one here the big limit. And again, because it's a different kind of limit. So if I change it here like to 100, then this should here change the output. And so now these are all the expenses that are bigger than 100. If I put bigger than just 1, then probably all of them will appear here, right? Let's put it to 500 maybe. Yeah, then we have only these two. Okay, so what can we improve here? Well, first, let's again change the name here to entry. Then here we can transform this string here, which has this plus, into a template literal, which is a lot more modern. So here we want then this part, and then simply this string. So none of this, and just like this. Now, just a small observation. We are taking the emoji out here of the string, which is this entry.description, by getting the last two characters. Okay, now that's because emojis basically count as two characters. If I had only one, like this, then we would get this weird sign here. All right, so it counts as two characters. Only then it works. Then we also have this small hack here, which is necessary because otherwise, in the end, we will have this separator here. But we will keep that here for now and fix it in the lecture after the next one. All right, then all we can fix here is to get rid of this ugly if and transform it once again into the ternary operator. So how can we do that? So we want to add something to the output conditionally, basically. So in case the entry value is less than the limit, then we want to add this, right? And otherwise, we don't want to add anything. And so that is just the empty string. Now we can get rid of this, and once again get rid of these curly braces. Give it a save, and here we are back. And now this looks a little bit better. So we say it's more declarative. So it's more readable. And you will learn actually what declarative really means in the next lecture. Okay, and I think that is actually it for this lecture. So we followed many of the guidelines of the last lecture. Now, of course, not all of them, because it's quite difficult to create an example which violates all of them. That would have to be a huge example, but I think this example is nice enough, and we will again improve it in the next lecture, or actually the one after the next lecture. So take some time and review what we did here, and again, if something is not 100% clear why it works the way it does, then just take a minute and review this code. And of course, take a minute to take another look at all the guidelines for clean and modern code that I showed you in the last lecture. And then after that, let's move together to the next one. So we just reviewed and also implemented some clean and modern JavaScript practices. However, there is currently a major trend and shift to something called declarative code and functional programming in JavaScript. And so let's now take some time to look at what declarative and functional programming actually are. So there are two fundamentally different ways of writing code in programming, which we also call paradigms. And these two paradigms are imperative code and declarative code. Now, whenever we write imperative code, we basically need to explain the computer how to do a certain things. So basically, we need to explain every single step that the computer needs to follow in order to achieve a certain result. But this might sound a little bit abstract, so let's try a more real-world example. So let's say that we want someone to bake a cake for us. And so if we would do that in an imperative way, we would tell the person exactly the step-by-step recipe that they would have to follow in order to bake that cake. All right? So again, it is telling every single step that the person has to follow in order to achieve a result. And now bringing that back into code, here in this code example, we are trying to double the R array. And so this loop that I have here is a purely imperative way of writing that. So here we are telling the computer step by step to create an empty array, to create a counter that starts at 0, then to increase that counter until we reach the length of the original array, and then how exactly to store the new result in each new position of the array. So there's a lot of steps that we really give the computer here in order for us to achieve the result of doubling that R array. Okay, so that's imperative programming, but on the other hand, we also have declarative programming, where the programmer tells the computer only what to do. And so when we write declarative code, we simply describe the way that the computer should achieve a certain result. But the how it should do it, so basically the step-by-step instructions, they get abstracted away. So we do not care about them. And going back to our cake example here, the declarative way of instructing someone to bake the cake would be to simply describe that cake to the person, and then the person would have to come up with the step-by-step recipe on their own. So simply describing the task and the result that should be achieved is the declarative way of doing it. All right. And now coming back to the code example of duplicating the values in an array, this is how we do it in the declarative way. So we have our array, and then we simply tell JavaScript that it should map the values in the R array to a new array. And each of these values should be multiplied by 2. And so if you compare this code example with the one on the left, then you will really see that in this example, all we are doing is to describing the way that the computer should achieve the result that we are looking for. We are simply telling it what to do, which in this case is to simply map the original array onto a new array and doubling all the elements. But all these super detailed steps that we have on the left side, like creating an empty array and initializing a counter, all of these steps have been abstracted away because we don't really care about them. All right? And this is pretty important to understand because more and more, this is how modern JavaScript code is actually written. So the difference between imperative and declarative is not just some theoretical difference. So the declarative paradigm is actually a really big and popular programming paradigm, which has even given rise to a sub-paradigm called functional programming. And functional programming is basically a declarative paradigm which is based on the idea of writing software simply by combining multiple so-called pure functions while avoiding side effects and mutating data. And actually, functional programming and writing declarative code has now basically become the modern way of writing code in the JavaScript world. So you will see declarative and functional code everywhere. And in fact, we have even been using it all along, but without really knowing that this style was called declarative and functional. Alright, but let's quickly go back to the definition of functional programming and talk about what side effects and pure functions are. So, a side effect is basically simply a modification of any data that's outside of a function. So, for example, mutating any variable that is external to the function is causing a side effect. So, basically, any variable that is outside of the scope of the function. All right? Now, data does not only refer to variables. So, for example, logging stuff to the console or also changing something in the DOM is also causing side effects. Now, next up, a pure function is a function without side effects. So, basically a function that does not mutate any external variables and that does also not depend on any external variables. So basically, if we give the same inputs to a pure function, it will always return the same output. And again, that's because it does not depend on any external variables, and it also does not manipulate them. And finally, if we look again at our definition here, we also see that functional programming is about avoiding mutating data. And we do that by using something called immutability. So in functional programming, state, which also means basically data, is never modified. So let's say that we have some application and we have an object there to keep track of all the data that we need in that application. And so that we usually call state. And so again, in functional programming, that state is never modified. Instead, what we will do is to copy that object, so that state, and then it is that copy that is mutated and can then be returned. But the original state is never touched. Okay? So that's what it means for the state being immutable. And the big upside of immutability is that it makes it so much easier to keep track of how the data flows through our entire application. And so ultimately, that will allow us to write better code with less bugs and code that is also more readable, which overall is the entire goal of using functional programming in the first place. Now, I'm telling you all this not with the goal of turning you into a functional programmer, because that would actually be a very hard task, because this is really just a very high-level introduction to what functional programming actually is. But behind the surface, functional programming is a huge paradigm which is really difficult to implement in practice. But it is still very important that you know some of these principles, such as side effects, pure functions, and immutability, because many of the popular libraries, such as React or Redux, are actually built around all of these principles. So, for example, in React, the state is also completely immutable. And so if you ever want to learn something like React, you will need to know about these concepts in order to use it properly. However, some principles, such as pure functions or side effects, can actually be a bit easier to implement into our own code. So what I'm trying to say is that we can actually mix imperative and declarative programming in our own codes. We don't have to go 100% declarative. Or in other words, we don't have to go 100% in the direction of making our code completely functional. And so, again, we can already start using some of the functional programming techniques in our own code base. So, for example, you can try to avoid data mutations as often as possible. And of course, this will not always be possible, but it's also not really necessary. So these are mainly just suggestions, but which will still create more readable and overall better and cleaner code. So another thing that you can do is to always prefer built-in methods or functions that do not produce side effects over the ones that do. And this is really important for data transformations. So whenever you want to do that, you should use a method such as map, filter, and reduce. So this is the functional and modern way of doing data transformations, and many times this is actually the first contact that many people have with functional programming. So map, filter, and reduce are actually present in all functional programming languages, and they are very important to implement functional code and more declarative code in our code. And finally, you can also try to avoid side effects in the functions that you write yourself. And again, this is of course not always possible and also not always necessary. So we will never be able to avoid all side effects in applications because, of course, at some point, the application needs to do something. So we need to display something on the DOM or log something to the console or really create some side effect. Okay, but you can still try to think about this and to start incorporating side effects more into your own code. And now to finish, let's come back to declarative syntax, because functional programming is only a part of using and writing declarative code. So in order to write code that is more declarative, you should use array and object destructuring whenever that's possible. You should also use the spread operator, the ternary operator, and also template literals whenever that is possible. Because if you think about it, then all of these 4 ways of writing code actually makes the code more declarative. So these operators are more about telling the code what to do and not exactly the steps that it should take, right? And that's, again, true for all these 4 pieces of syntax. All right, so let's now actually continue working on the code example from last lecture and implement some of these functional programming principles in practice. Welcome back to continuing to fix the code that we started to work on a bit earlier. And so in this lecture, we're going to focus on some of the functional and declarative principles that we learned about in the last video. And we're going to focus on 3 big areas of functional JavaScript, just as we talked about in the last lecture. So that's first, immutability, second, side effects and pure functions, and third, making data transformations using pure functions such as map, filter, and reduce. And let's actually start with immutability, because in JavaScript, there's actually a way to make a data structure, or in other words, to make an array or an object immutable. So let's take a look at that. So let's go back here. And so what we can do is to call the function object.freeze. Then in that function, we pass in the object that we want to make immutable, basically. So by doing this, spending limits is now immutable, which means that we can no longer put any new properties into it. So let me show that to you. But actually this works best in strict mode, which I'm noticing here is actually not activated in this script. But we already know how to do that, right? And so let's see what happens if we try to add a new property to spending limits. Let's say we want to add J actually, because we have him down here. And so let's say we want to actually allow him now to spend something as well. So let's say 200. Let's give it a save. And if we now check out this object, then you see that it didn't change, right? And so that is object.freeze for you. So whatever we try to add now to this object is not going to work because it has been freezed. So let's do the same with this one here, because in the end, an array is also just an object, right? And so we can also do object.freeze on arrays. Just like this. And now we actually already start running into trouble, because down here we are trying to push something into this array, which is now no longer possible because, again, we made it immutable by using object.freeze. So right out of the gate, this code here is now no longer working. Now, I actually wanted to show something to you. So let me remove that. But there's probably still going to be an error down here. Well, actually not. And yeah, there's a reason for that, which I'm going to describe now. So you saw that we can not add new elements to this object now, right? So that was the reason for the error that we just saw here. However, object.freeze here basically only freezes the first level of the object. So it's not a so-called deep freeze because we can still change objects inside of the object. So for example, I can do budget and then the first element and then dot value. I can set it to whatever I want. And so if we see now the result here, you see that the value did indeed change. All right. What I cannot do is to add a completely new element. So I cannot say, let's say, object 9 should be Jonas. So that is not going to work. So you see nothing was added here now. All right. So that's just something to keep in mind when you use object.freeze. Now there are, again, third-party libraries which implement a deep freeze, but I'm not going to go that way here in this small and simple example. Let's just take out this one here, and then let's keep going. All right. So let's put these back, and that will then bring back our error. And so now we will need to fix this function. So how do we fix this function, and why does it create the error in the first place? So the problem is that right now this function at expense is trying to mutate this outside object. So in other words, according to what we learned in the last lecture, is that this function right now has a side effect, right? So remember that a side effect basically means that something outside of a function is manipulated, or that the function does something other than simply returning a value, right? And so a function that has or that produces side effects is called an impure function. So this function at expense right now is an impure function because it does attempt to manipulate and to mutate this object that is located outside of it. So how do we fix that? Well, first of all, we should always pass all the data that the function depends on into the function so that it doesn't have to reach into the outer scope. So that's the first good practice. And then, of course, the function should not change any of these values. So in other words, it should not mutate them. And that's the whole reason why we made this object here immutable, just so we cannot by accident mutate this object, right? So remember that the solution to that is to create a copy and then return that copy of the state, so of the data, right? So I just said a lot of stuff, so let's put all of that into practice here right now. So the first thing that I'm going to do is to pass in a variable called state, and then also the limits here. Okay, so this state here will be the budget object, and then here the limits is of course going to be the spending limits. And so I will pass in all of that here in all of the three function calls. So budget and spending limits. So that, of course, alone does not fix the error, but we are working in the right direction. Okay. Now, I said in the last lecture, or in one of the previous ones, that we should not pass more than 3 arguments into a function. Now, in this case here, we actually have 5 parameters, but, well, sometimes it's not a big deal to break those rules. We could also pass in simply one object of options, basically, But let's keep it simple here. I'm not into the mood of changing all of these inputs here. All right, so this is just fine here. Then next up, here we are clearly manipulating the user variable, so the user argument in this case. And so, as we learned in the last video, we should avoid these data mutations whenever possible. And so let's instead simply create a new variable right here. So let's call this one here clean user, because we are basically cleaning it. This is a common terminology that we use. So this is the whole reason why this Matilda here, even with the capital M, still works. Okay, so I didn't mention that in the previous lecture where we worked about this, but without this piece of code, it wouldn't work, because Matilda here is uppercase, but here in the object, it is lowercase. And so with the uppercase, it would not be found here in the object because this here is lowercase. And so that's of course different. And so here we will always convert everything to lowercase so that it then corresponds to the object keys that we have here. So this one here is from before. Let's actually put it here where it belongs to. So that was the alternative way of getting the limit. Then here we need to use that clean user and the same here. So we still want this to be called user. So here we need to go back to saying user should be equal to the clean user. Okay, so we did most of the work here, but now actually comes the main part. And again, that is that we want to replace this manipulating of the object by creating a new object based on the state that we receive. All right, so let's get rid of this code here. And instead, what do we want to do? Well, we basically want to return an array like this here, but simply with one more object. So we learned already how to do that actually previously, and it's not very difficult. So let's just say we want to return then an empty array, and then we use the spread operator to put all the elements of the state in there. And so this effectively creates a copy of this state array. Remember how we did that earlier? And so this is exactly the same technique right here. And now all we need to do is to then add a new element right after this one. And that element is going to be this object, which looks exactly like what we had before. All right. And so now we can get rid of this. All right. So right now, calling the addExpense function will actually no longer mutate the budget object, right? And so therefore, if we want to then do something with the new budget, we actually need to store that somewhere. So let's say new budget 1 is equal to this. Then let's quickly log it to the console as well. And so let's see, and here we are. So here is pizza. So that's just the expense that we added here previously. Great. But now what happens if this here turns out to be false? So basically if this code here does not run. Well, let's try that by making this pizza here ridiculously expensive. And so you see that now we actually get undefined. So that's not good, right? And so what do you think we should return in this case? Well, what we have to do is to return the original state. So the original budget that we got in, right? And so in that case, the addExpense function will always return something. So it either returns the original budget or it returns the one with the new expense added to it, right? So let's clean this up here a little bit and simply use the ternary operator here. Because remember, that is a lot more declarative than the more old school if-else statement. So here, let's take away the return and actually put that here in front. So here we will now decide what is going to be returned. So in this case, what we will return is this new state, so this new budget, or otherwise we will just return the original one. Now we got some errors somewhere. It's this one. And here we go. So now we no longer got our error and we are returning the original budget here. And if we put it back to a normal price, then here we go. So here is our object, our updated expense. So our updated budget, but in a functional way. So right now, this function here does no longer produce side effects. It is now officially a pure function. Let's actually write that here, because we're really happy about this now. All right. Now, what about this one here? So the next add expense call. So do you think we still should pass budget into this one here? Well, not really, right? Because this one will then again act on the original budget. And that doesn't really make a lot of sense, right? Because this previous expense that we just added is not going to be in there, is it? So let me show that to you actually. Put that down here and create a new one. So let's see. And so here, now we have going to the movies, but indeed we don't have the pizza here before. And that makes sense, right? Because we are again using the original budget, which was never mutated by the previous add expense call, right? And so what we have to do instead is to here pass in the result of the previous operation. So that's new budget 1. So if we see now it will have indeed pizza and going to movies. And then, of course, the same thing here for the final part of the puzzle. So the final expense, the third one. And here then we again use the previous one. So that's new budget 2. But now this one here should be the same as before because, of course, J is not allowed to add anything. Right. So only pizza and going to movies has been added there. Let's make this one here a bit smaller so that it fits in one line. Well, it didn't. All right, so let's just leave it like that. And yeah, so that first part here is now fixed. Now, in the real world, we would use something called composing and a technique called currying to basically create this chain of operations here. So here we need all of these intermediate variables to create a new budget, right? So we call this once, store the result in a new variable, then the next call we use that previous variable, and then again in the next call we use that previous variable again. So this is kind of a chain of add expenses, and it would be nice to always automatically use the previous result for the next operation. And so again, in a real world big functional application, we would use composing to create one function which will then perform all of these operations at once. But that would really be outside the scope of this course because that is a whole big world on itself. So here we are just trying to implement some of these techniques and some of these concepts just so you see how they work and that they exist and that they are important. And again, this becomes especially important once you start using one of the frameworks out there, just like React or Redux, which rely heavily on concepts such as immutability and pure functions. But anyway, let's now move on here in our code. And now that we already talked so much about side effects and immutability in pure functions, let's turn our attention to data transformations here in this case. Because as you see, here we have this for off loop, which we can easily transform into a functional function, basically. So we have this loop here, which loops over all the entries in the budget, right? So basically, which loops over this array, and in each iteration, the current one is one of these entry objects. And then in this loop, it will update each of the objects to contain the flag attribute, basically, whenever the value is over the limit. So that happened, for example, here. And so we got flag set to limit. Remember that from the previous lecture. But of course, this function is again an impure function because it does manipulate the object itself, right? So in this case, it works with a budget, but the same would be true if we wrote new budget 3 here, which was our latest and updated budget. So this one here actually comes from line 65, so it's this one. So what I would be interested here is this. So let's move that down here. And so here indeed we will now see, so here is flag set to limit. And so we violated the principle of immutability here, right? And therefore, let's transform this function here into a pure function as well. So again, we will want to pass in all the data that the function depends on. And so that's again, well, in this case, it is budgets 3. So new budget 3. And also, we actually need the limit from the outside. And actually, we skipped this function here, but let me come back to that in a minute. So let's just pass in the spending limits here as well. So let's go back up here. So we passed in the spending limits here into the add expense function, but we actually never used it. And so the reason for that is that get limit here actually uses the spending limits from the outer scope. And that's something that we do not want, right? And therefore, let's add the limits here as another parameter. Limits and user, and then here I can just call it limits like this. And then here I pass the limits in. All right. So it works just like before, but now this function here no longer depends on any external variable. It can do all its work without having to look up in the scope chain. Now, okay. So let's do the same here as well. So here we want to then receive a state. I'm going to call it state to keep it neutral, just like before, and then calling it limits once again. So here again, we want to pass in limits and then the user itself. But now let's then finally actually replace this entire loop and instead loop over the state using one of our data transformation functions. So what do we want to do here? Well, we want to basically keep an array of the same size here in the end, right? So in each of these objects, we basically just want to add a property, but that's all we want to do. We don't want to filter anything, or we don't want to use reduce either, right? So it makes sense to use the map method here. And map, remember, will create a brand new object, so a brand new array. And so that's exactly what we want, right? So that's in the spirit of functional code and of immutability. So not mutating the state, but instead creating a new state based on the original one. And so, in fact, this is then the state that we are going to return from this function. But let's not get ahead of ourselves and instead work here on this. So let's create a function block here and think about what we want to do here. So right now here inside of this callback, each entry is one of these objects, just like this, right? But of course, we still do not want to mutate any of these objects, right? Instead, when this condition here is true, so when the value is less than the limit, then essentially we want to copy the object and add the new property onto that copy, right? So basically just like we did here. So the idea is the same. So here we copied the entire array and then added a new object. But here what we will do is to basically copy the entire entry object and then add the flag property to that. So that sounds a bit complicated, but trust me, it will all make sense. So let's copy this condition here, just like this. And then again, making the code nicely declarative by using the ternary operator. So if this condition is true, so if the value is above the limit, then here we want to return the original object copied. So remember that this creates a copy and add a new property. And so that's flag set to limit. And otherwise, what we will want to do is simply return the original entry. And that's actually it. So let's just check out the result and then I will show it to you again. All right. So here, now of course, we need to again store the results into a variable. Let's call this one final budget because we will not create any new budgets. And I'm then going to log that here. And so let's see if we got the flag here. And indeed, flag is set to limit. So that worked. And you see that we did not actually manipulate any object. All we did here was to create a copy and then add the property onto that copy, right? Now here you might not be used anymore to actually see the return here in the map callback function, but that's just because we have this function block here, right? And so remember that in the map function, whatever is returned from the callback will be the element in the same position of the new array, right? So that's why we need the return here. But of course, we could also completely simplify all of this here if we wanted to make it simpler. So let's take this and actually transform it into an arrow function if you prefer that. So I will then leave these two here. So function and state, then let's say just like this. Then we don't need the return. And here we can get rid of the braces as well and of the return. Let's call this one here 2. And here we don't need that semicolon, I guess. And that's it. Now we're ready to go. And this is basically the same function. Just copy it or actually comment it out. So just in case you prefer this arrow function. So I hope that this made sense. What's really important to note here once more is that we transformed this function here into a pure function which does not mutate anything because the map method here returns a brand new array. So we give this function an array and it will then create a new one simply by mapping over the original one, which again creates then a brand new one. And in each position of the array, we then either return a copy of the original entry plus the flag property, or simply we return the original entry as it was. And so with this, again, our function is nice and pure and does not create any side effect and does not manipulate anything. Nice. And maybe you're actually noticing that throughout most of the course, we actually kind of followed these principles already, but without calling it functional. And I remember especially the Bankist project, so in a section about arrays. So in there, I told you a lot of times that we should always pass all the data that we need for a certain function to work right into that function. So that, again, it does not depend on any outside data. Because really, you will see in practice that this makes it a lot easier to reason about the function itself. And so if you do that for all of your functions, then in the end, that will make your code a lot easier to understand and a lot more readable. Okay, but with that being said, let's now move on here to our final function. And here again, we have this for loop. And inside of that loop, we are actually constantly manipulating or mutating this output variable here. And that, of course, goes against the spirit of immutability, right? So immutability is, of course, not just for objects and arrays. This also goes for more regular variables. And so in functional code, you will probably never see the let variable. So we're always trying to compute a variable, for example, based on methods like this one here, right? And so here we will actually be able to achieve something similar. So let's think together how we could create a string like this here, simply based on pure and functional functions. So data transformation functions for arrays and also for strings, actually. So let's comment all of this out because, of course, there is going to be a better, more declarative and functional way. So in the code that we had here before, of course, it was very imperative. We said create an empty variable, then we manually said that it should loop over all of the entries in the budget array. And then whenever we had a big expense, which is basically this one here, it should then add the emoji to the output variable here, so to this string, right? But if we really think about this, there is a better way to doing this. So this one here is called output, and I guess we should just actually call it big expenses. So you could have done that before, so giving it a better name. So what we really want to do, and this now I think requires a little bit more thinking on our part, but believe me, it's going to be worth it. So what we really want to do here is not all of this imperative stuff. So what we want to do is actually just filter our array for these big expenses. And then basically for each of the results, all we want to do is to create a nice string containing only the emoji. So let's translate what we just said, and starting with the filter. So entry, and then here the condition is of course going to be the same. So basically an expensive or a big expense. So let's start by logging this here just so we can see what we're doing. Big expenses. And here we say that the state is not defined, and that's simply because I didn't pass it in yet. So just like before, of course, we want to make this function not to depend on any variable from the outside. And so we pass it in here as final budget. So let's see what we have here. And indeed, that is the new iPhone and laptop, which are exactly or big expenses. And so now all we need to do is to get these emojis here out and then create a nice string based on the result. Right? So we have now this array of 2, and so we want to again create an array of 2, but only with these emojis. So let's use a map for that. So again, that is an entry. And here we want the entry dot description, and then just take the last 2 characters. So just like we did here before. All right. And now we can just join that like this as we had before. And there we go. So this here is essentially the functional version of just doing this here. So after this video, you can maybe take a better look and really compare these two things that we did here. Let me just show you that we could also have done it in another way. So instead of map and join, we could have done it all in one go using reduce. And so once again, this is a nice use case of showing you a more advanced way of using reduce. So again, the use case of reduce is to basically take all the values in one array and create one value out of them. So reduce them all into just one. And in this case, what we want is our string. And so that's going to be the accumulator. And then, as always, we have the current value, then here a callback, and then the initial value, which is just going to be an empty string. So what we want to do here is to basically always return the previous string plus the current string. So that's the previous string and then the current string, like this. And of course, we still need to say .description.slice, like this. So we're almost there already, just missing this separator. And there we go. Now we just have this ugly thing here. Let's see what happens if we remove this here altogether. And yeah, of course, that cannot work. We always need an initial value. And so now we could go ahead and only start reading here, but that's not really necessary. So we can, of course, go back to using just this code, but that's not going to be necessary. Of course, we can just go back and use this code right here and take out this one. So this was just yet another use case of the reduce method that I wanted to show you here, so that we can create even strings using reduce. All right, so I'm leaving this here again for you to compare, give it a save, and I think that with this we are done. So we transformed our initial code, which looked pretty bad, first by applying some general guidelines for modern and clean code, and then now in this video we made our code functional and took out all of the impure functions and side effects and data mutations. So a lot cleaner, a lot nicer, and also, if you ask me, a lot more professional looking code. Now, actually, this function here is not pure. Let me just write that here. So it's an impure function because it creates a side effect by doing this console.log here. Okay? So in fact, all console.logs here are of course impure because they do something. So they create something here in the console in this case. So they create input output. But of course, any program needs to have some side effects, because otherwise, what is the point of the program in the first place? If we didn't have all of these console.logs, how would we even know that the program is running in the first place? Right? It would not be useful at all. And so, as I said, we always need some side effects, but in functional programming, we try to push these side effects as far to the edge, so as far to the end of our program as possible, so without having them all over the place polluting our application. Now, this kind of mini project here is, of course, very far from being complete, and if you wish, you can, of course, develop this a lot further. For example, you can add a function for adding the income, or you can also create functions for calculating the total expenses and incomes, the overall budget, how much the expenses are in percentage of the income, and so on and so forth. But I will leave it like this here, because again, this is enough for us now, and our code looks pretty professional as it is. Just keep in mind again that these are more like guidelines and not really hard rules. So large applications, they are very hard to make 100% functional, and that's absolutely okay. So actually, right in the next project, we will already break many of these rules. And again, that's okay. It's not a big problem. as long as we try to still keep some of these principles in some of the places, we're already making our code a lot better and a lot more professional. Now, okay, and with that being said, you're now ready to go build the biggest and kind of the final project of this course in the next section. And so I really hope to see you there soon.